lesson's going to be all about fractions, decimals and percentages. Okay? The reason we do them together in one big lump is because they're the same thing. A fraction is the same as a decimal, is the same as a percentage. We just write them in different ways. A half is 1 over 2. Sorry. And everybody knows a half is 0.5, and everybody knows 0.5 or a half is 50%. Okay? So the whole premise of today is we're going to deal with the hardest thing, the fractions, really slowly. Okay? The speed is dictated by the other lessons that stopped at objective 4. So today's objectives are going to be the first 4. We'll forget the bottom 4, okay? So we're going to define equivalent fractions. I'm going to teach you to add, subtract, multiply and divide fractions. We're going to use decimal notation, and we're going to recognise recurring decimals. But within that, we're going to do other things as well that will make you really sound on fractions. And I'm going to do it in a different way than I did last year. Rather than teaching you tricks, I'm going to teach you the fundamentals of fractions and how we add and subtract. Okay. Last year I just showed them tricks on how to add and subtract. This year you're going to understand why we do those tricks and really get to grips with fractions. Because fractions are kind of at the core of people. Most people, when they say, oh, what you struggle with maths, they say fractions and then they put ratios in. Well, they're the same thing. So if you can handle fractions, and I put a bit of effort in today about really understanding fractions, when we come on to ratios next week, it'll be a lot easier for us all. Okay. So there is method in my madness. Right, my cunning plan is still just hanging in there, just about. We're on week 2, we're starting fractions, decimals and percentages. For Harry's benefit, the green is unit 1, the blue is unit 2 and the red's unit 3. You're going to take 3 exams when you get to next June. As you can see at the start, a lot of the boxes are all 3 colours. These are what we call the basics. They apply to all 3 of your units. You will get tested on them. But we're going to do unit 2 first because it's got most in common with everything else. So by the end of November, you'll have finished unit 2. We're going to do a practice paper beginning of November. You're going to show me that you've understood everything in unit 2. And then we're going to carry on and do unit 1 and unit 3. Your near-term goals are to really get to grips with these basics. And to help you do that, we've got something called My Course that I'll log you on to, Harry, and we'll make sure you know where everything is you need to catch up and get to grips with each of these subjects. So in week 6, so only in about 3 weeks' time, we're going to be doing what we call a continuation assessment. That is to make sure you've got to grips with the basics before things start getting really hard. Okay. Right. We have to do this. We're an enterprise college. We need to train you on selling yourself when you go for interviews and jobs. The college has got some headline skills that you should have in communication, innovation, enterprise, digital literacy, self-development, workplace literacy, and delivering results. The idea of this slide at the start of the lesson is I say, you're going to practice your listening and understanding by listening to what I've got to say and understanding it, showing you understand it by doing something, okay? You're going to design solutions. I'm going to give you problems that require you to come up with a solution to solve. Commercial awareness and financial awareness are right in there today. Where do we come across commercial things a lot with what we're covering today? Think about fractions, decimals, percentages.
Like discounts in shops.
Brilliant.
And stuff.
Yeah, every day, 10% off, 15% off. You'll be able to do them like that when you finish this little bit. Okay? Going to use online resources. That's an absolute must with this course. This course is 3 hours in the classroom, and I would expect you to do 3 hours out of the classroom every week to stay up to speed with everything we cover. Okay, so it's not about 3 hours in the class. If you just do the 3 hours in this classroom every week and do the homework I give you and that's it, you will not pass this course. The only way you pass the course is by doing as much out of the classroom as you do in the classroom. Okay, self-analysis and using feedback, you're going to start seeing that now. You're going to give me homework that I gave you last week. We'll provide feedback and you'll react to that feedback. And finally, decision making. We're going to give you some problems. I'm going to ask you some decisions on the way we should approach fractions and percentages and decimals. And we'll approach it in whichever way you decide as a group that we want to do. Okay, the ground rules, just for those who haven't been before. Good attendance, completing work and being punctual are the top 3. The feedback from the course that passed last year's exam is the most important thing is doing your homework and doing it to a good standard. Not attempting a question because you don't understand it is not good enough. And putting a question mark there isn't good enough. You need to go away and research it and work out why you can't answer that question. And that's what learning is all about. DIY, do it yourself. So when you're in the class, we do get big classes where everyone's huddled in together. People are always looking at their mates and You don't learn by copying, you learn by having a go yourself. If you can't manage it, we'll always do it on the board afterwards and go through it, okay? So we'll always check your answers and you will become your own worst critic, yeah? You will mark your own work, you will decide what you need to go away and work on when we go through these lessons. And these lessons are quite quick. Okay, quick reminder on last week. So we'll always have a look at what we did last week. So we talked about integers. An integer is what? Anybody remember what an integer is? Yes, Sam?
A whole number that can be positive or negative.
Brilliant. First person this week that's given me the textbook answer. Everyone goes, oh, it's a whole number, but it's positive and negative, okay? And we talked about negative numbers. Negative number is less than 0, but we said there was an order to a negative number. So if I said to you, what's bigger, -2 or -6, what's the bigger number? -2. So the bigger the negative number, -32, the lower it is, okay? So that's an order to negative numbers. And we talked about bank accounts and temperatures being the two main ways to deal with negative numbers. And we talked about words that 16 to 18-year-olds may not have come across a lot, like deposit, credit, debit, and you need to know all those. When we did some division, we talked about something called a remainder. We didn't carry on doing the division, and that will come out today, and we'll use that in fractions, and that's quite an important skill. So when you do your division, rather than carrying on dividing, we said, 4 goes into 9 twice, remainder 1, and you'll use that today, okay? Sum, difference, product, and quotient. We did some basic add, subtract, multiply, and divide. What happens, Harry, is you'll get questions that use these words, that if you don't know what the word means, you can't answer it. So if I said to you, Sharon, what is the product of 2 and 4, you would say straight away,
I don't know, I forgot.
You've got an exam in November, so you need to know what it means. Anybody that was here last week? Sam? 8. Product is the result of multiplying two numbers together. And they've used this word in a lot of exams lately. So the word product means the result of multiplying two numbers. What's the product of 3 and 4? 12. Okay? If you don't know the word, you can't answer the question, you've thrown an easy mark away in the exam. We talked about the sign rule last week. Anybody remind me what the sign rule is?
If both signs are the same, it's a plus.
If the signs are the same, it results in a plus.
If they're different, it results in a minus.
If the signs are different, it results in a minus. And we applied this rule to adding, subtracting, multiplying, dividing. So we did the basics of add, subtract, multiply, and divide with nice positive numbers. But then we did it, and we introduced negative numbers, and we started getting funny things like 5 plus -2. So I'm adding the number -2. And we used these rules to solve that. And we said, what's the golden rule when we're adding, subtracting?
Whatever's within the two numbers.
It's the signs that are stuck between the two numbers. So what's the resultant of an add and a subtract? Our sign rule tells us a subtract. So it becomes 5 minus 2 equals 3. That's what the sign rule is. It tells us how to deal with negative numbers when we throw them into our standard add, subtract, multiply, and divide. If I said to you -3 times -2, oh, then you wrote 3. Okay? What is the result of that? Harry, looking at it like you're going to answer?
Is it, would it be 6?
Brilliant. It's +6, but we're lazy in maths. We know positive numbers have got a plus in front of them. We just don't write them, okay? So this time, our sign rule applies to the signs that are in front of the numbers. So a minus and a minus is a plus, but we don't write a plus. 3 times 2 is 6. So nice one, Harry. Great start. We then talked about something called bid mass. Remind me what bid mass is? Anyone? B? Start with a B. Brackets, okay? So anything in brackets we do first. Next, I. What's an indice, Sam?
It's the little number.
It's the little number above the big number. Yeah? So what am I doing there? What do we call that? An index? What else do we call it?
No.
An order or a power. So sometimes you see the word bid mass, sometimes it's bod mass because they call that an order, or sometimes it's called a power. We're going to call it an index because we've got a whole lesson on how to deal with these little things. And what does that mean then? When it says 4 to the power 2, what's the instruction in maths telling me to do?
4 times 4.
4 times 4. So 4 squared is 16. A lot of people say it's 4 times 2, which is 8. It doesn't. It's saying this little number here tells you how many times to multiply what we call the base number. So 4 to the power 2 is 4 times 4, which is 16. So if you've got anything with an index, that comes next. The sorry, the D and the M, what do they mean? Divide and multiply. And why have I got a little red thing hooking them together? Yes, Sam?
Is it the same value?
They're at the same level. So if I have 2 times 3 divided by 4, they're at the same level. I just go from left to right. What's the A and the S? Add and subtract. And that's the same rule as well. Anyway, bit late, but hey ho, you're an adult. You're taking these car troubles, is it?
No, it's to drop everyone off, don't I?
Oh, right. Okay. Don't worry, next week we're starting at 5:30.
Oh, wait?
Yeah, just for you. We had a vote and we said, oh, Sam can't make it on time, we'll start. Right, sorry, Ben.
It's all right.
Right, so that rule of A and S in bid mass, okay, is exactly the same. So if I said to you 3 minus 2 plus 4, because I've got just subtraction and addition left, don't think A comes before S, because if you do the addition first, you end up with 3 minus 6 equals minus 3, and that is the wrong answer. You should be reading it from left to right. So what do we end up with, Fee?
3 minus 2 plus 4.
So 3 minus 2 is 1, so you do that first, and then you plus the 4 equals 5. You end up with 2 totally different answers if you do it in the wrong order. So at this very early stage, sort out in your head, the A and the S are on the same level, and when you're left with A and S, just read them from left to right. And I'll give you a handout sheet with some practice on it. We did it last week. Okay. Then we finished last week with a bit of rounding, and we talked about nearest significant figures and estimates. And we're going to do a bit more of that today, but with decimals, okay? What was the golden rule with rounding?
5 up.
The number 5 goes up. Think of it with balloons like we did. Okay? And then the golden rule is you go to the number they're telling you that you're interested in, look at the next one along, and make that decision based on the 5. Okay? If it's 4 or below, you round down. If it's 5 and above, you round up. I'm going to do exactly the same technique today with decimals. Okay? Everyone happy with what we covered last week? That's on my course, that slide. Okay? So you can go on there, remind yourselves before you come to lessons that that's what we covered in the week before. And we'll stick it up every week just as a reminder. Here's a smart recap. When we have a go at 4 things that we covered last week, the top one is by far the most important. As easy as it looks, there is an incredible learning point from that first question. Okay? So have a go at those 4, see how you get on. We don't mark anything in here other than homework, strictly, Harry. So just be your own worst critic and mark your own work. We'll share out the work between us. I like this work share scheme. Okay, I'll clean the board while you're all doing that. Did you get my email address, Harry?
Yeah.
Great. Sorry about that.
I have them somewhere.
Oh.
Yeah, you're right.
You want some pens or something?
No, it's just...
My head's all over it, sharks.
Yeah. Deep breath, calm down. It's no race. It's not a race today. Okay. So next week, 9:30 start, which is not good for me. I'll do it. Means I leave the house half an hour later, but it takes me 20 minutes longer to get here. 4 questions, not particularly difficult, but it's all about the techniques that we learned last week. Don't worry about these techniques, you will practice them week in, week out. The reason they're called the basics is because they appear in almost everything we're going to be doing. Okay, right, let's go through these then. Any volunteers for the first one, the most important one? Harry? Sorry?
6.
Brilliant, yeah, absolutely. Don't worry about it. We did a basic addition, subtraction, multiplication and division last week, okay? The really important learning point from this is, in maths, we can write divide like that. How else can I write division in maths? Anyone seen another way of writing it? What's that? Sharon, speak out. I've got 24.
Yeah.
And what?
In the thing, not
Oh, you mean in the bus stop? Yeah, that's how we actually do the division. But what's another way of writing that, Sam? A line, how?
Diagonal.
Not a diagonal, underneath.
underneath.
So if I wrote that for you,
Yes.
does that ring any bells?
Fraction.
Looks like a fraction, doesn't it? Just a top heavy fraction. It's a
Top
fraction.
yeah.
Has everyone seen that as another way of writing divisions?
No.
Never.
Well, I have a bit with you, but I wouldn't.
I hope so. You spent 9 months with me.
Only because of you.
Right.
Though.
So it's all my fault. Right.
Yeah.
So 24 with a line and the 4 underneath is another way in mathematics of writing that. Doesn't that look dead familiar? It will be by the end of the day, trust me, okay? All a fraction is another way of writing a division. And that's going to be part of our concept today. Don't wind yourself up with fractions, just look at it as a fraction, as a division you haven't calculated yet. And that's how we're going to use it, okay? This one here then, -3 plus -2. Any volunteers? Yes, Sam?
-5.
Talk me through it, don't just give me the answers.
The plus and the minus.
Plus and the minus is a minus, so I end up with -3, -2, and as Sam says perfectly correctly, gets -5. If you didn't get that, if you have issues with negative numbers, think of the number line, okay? Next one, -10 times -50. Yes, Harry?
2 minuses make a plus, so it
Brilliant.
turns into 500.
10.
Oh, it's 5,500.
Right, you're confusing yourself. Last week we multiplied with lots of zeros. What was the golden rule when you got lots of zeros?
Shift
Just
them
take
over.
them off and take them across. So I've got 1, 2 zeros. Just stick them over there. They're out of the way. So what does that leave me with? 5 times 1. Just stick it in front. Okay, last week we did a bit of practice on this with lots of zeros. Move the zeros out of the way. Just do the basic numbers. And then 8 minus 2 plus 4. Sharon, talk me through that one.
8 minus 2, 6.
So you
4
did
is 10.
left to right, and then, yeah, and the answer, 10. Brilliant. Okay, just a bit of bod maths, work your way from left to right. Don't be suckered into doing the addition before the subtraction. Okay. Absolutely fantastic. Everyone happy with that? Any brick walls we've hit yet? No? Great. That's super. Right, let's move on to the main course for today. I'm going to talk about fractions. You've all probably seen diagrams like this, or pies, or little plastic sticks that split up into parts or whatever. It's a way of representing fractions. All a fraction is like we say, is a division. I've got something, and I'm going to divide it into an equal number of parts, okay? I've got one thing, and I'm going to divide it into 2 equal parts. That happened twice yesterday. It's like there's a ghost
Spooky.
in it. Yeah. And the thing is, I've triple checked it, and
There's no other.
it doesn't pull towards, it's not like a dodgy catch or anything. Happened twice yesterday. Right. Starts happening on a Wednesday night when everyone's gone, I'm out of here. Right. So all I've got is something I'm dividing into a number of parts. And just think of fractions like division. I've got something and I'm dividing it into 3 equal parts. The obvious thing that comes off an image like that is the bigger the number on the bottom, the smaller the part I'm getting, okay? And you're going to be asked to compare fractions. And they might ask you something really basic, like, which is bigger, a half or a tenth? Well, a half is bigger. If I had half a pizza, I'd be eating a damn sight more than a tenth, okay? So what we're going to do today is we're going to approach fractions in a slightly different way, okay? And we're going to look at them like that. So we've already talked about this. What does a half represent in mathematics? What does it mean mathematically? We talked about it earlier. First question on your recap.
Half of it. What's it?
It means 1 divided by 2. That mathematically is what it means, okay? I've got 1 of something and I'm dividing it into 2 equal parts. I had 24 of something and I divided it into 4 equal parts. It gave me 6. This time I've got 1 of something and I'm dividing it into 2 equal parts. Let's do that mathematically then, okay? If I was going to do that as a division, what would go into the bus stop?
2.
The 1 or the 2. It's the 1 being divided, so the 1 goes into the bus stop, and the 2 goes out the bus stop. So the thing doing the dividing goes out the bus stop. So when we had 24 divided by 4, you put 24 in the bus stop, 4 outside, right? So let's do this mathematically. But this week, in this instance, we're not going to stop and do remainders, okay? 2 goes into 1, it doesn't. Put in a decimal point, carry the 1 and put in an invisible 0. How many times do 2 go into 10? 5 times. So what we're saying is, when I have a half, and I actually carry out that calculation, and I divide 1 by 2, it gives me 0.5. That's why a half is 0.5. And to quite a few people, that comes as a revelation. They've always known a half is 0.5, but they've never known why is a half 0.5. Does that make sense? Yeah? So a half is representing a division I haven't done yet. 0.5 is actually representing what happens if I carry out that division. Yeah? All right with that concept? Yeah? A few eyebrows coming up and down. Okay. Yeah? So really, we're talking about the same thing, just a different format, aren't we? Yeah? One's a division that hasn't been done, the other is actually the result of that division. Brilliant. Okay. So let's talk about our fractions then. We've talked about the order of fractions. Let's talk about the proper terms we use in fractions, okay? What's the number at the top of a fraction called? Let's talk about fractions today. Okay, and they've got an order. So, what's the number at the top of a fraction?
On
The numerator. Numerator. And the number at the bottom? Denominator. Thanks, Sam. Denominator. There's some cracking words the other day. Some of them aren't repeatable in a public audience, but numerator and denominator. And I put a little line there just to give you a little reminder on the board that the one at the top is the numerator and the one at the bottom is the denominator. And I'm going to start using that in the lesson so it kind of sticks with you. So when we're talking about the number at the top and the number at the bottom, start using the mathematical terms. It's very rare they'll test you on those terms in an exam, but it's good that you understand maths terminology, okay? So, as we said, fractions have got an order. However, when we're comparing a half and a tenth, it's dead easy because the numerator's the same. Okay? And 1 compared with 1 is dead easy. 1 half compared with 1 tenth. But if I said to you, what's bigger, 3/6 or 4/8? They're actually the same thing. But you can visualise it on here. We need a technique to actually compare apples with apples. Because when you have different denominators, they're like apples and oranges. You can't compare the same thing. Okay? So what we're going to do today is we're going to teach you a technique to compare apples with apples. And that technique will not just let you order fractions and decide when you get horrible ones which is the bigger or smaller. It's also the technique we're going to use for adding and subtracting them as well. Okay? And this technique is called equivalent fractions. It's where we're going to play around with the numerator and denominator, but we're not going to change what the fraction actually means. Okay? So let's have a look at this technique, shall we? Equivalent fractions then. I've got a pizza. Very keen of my Domino's on a Saturday night, watching the X Factor. Not really. Can't stand it. Right. That's X Factor, not the pizza. Right. So I've ordered a pizza. Get the old cutter. I cut my pizza in 2. And cutting it in 2 is what the denominator is about. Okay? How many pieces have I cut my pizza into? The numerator is how much I eat. And I'm going to eat one of those 2 pieces. Okay? So I've eaten half a pizza. Right. The next week, my wife gets to the pizza before me and she cuts it into 4 and says, you're on a diet, right? I'm going to cut it into 4 and you're going to eat less. So she's cut it into 4 and I have 2 of those pieces. Have I eaten more or less that week?
Same.
So you can all see that a half is identical to 2 over 4. The next week, my brother's visiting, he cuts it into 6 and I end up snaffling 3 pieces. Have I had more or less?
Same.
Next week, my mum's visiting, Pete, you're putting on weight. I'm cutting it into 8. And I said, okay, I'll have 4 pieces then. I've had more or less. Same. Okay? So, going from left to right, I've eaten the same amount of pizza every week for 4 weeks, okay? But the denominator's changing and the numerator's changing. Can you tell me, what's the pattern then? What have I done? How have I gone from a half to 2/4, yet got the same fraction?
You just cut it more.
You've just halved it every time.
I haven't halved it every time. What have I done from getting to there to there?
Yeah.
Yeah, I've doubled it. I've multiplied this by 2, but what have I done to the top and the bottom?
The same.
I've done the same. So if I do the same to the top of a fraction that I do to the bottom of a fraction, and this is the one main learning point of today, the fraction doesn't change. It's what we call equivalent. Yeah? Does that make sense? So let's look at the next one along then. I've got a half. What have I done to get 3/6? I've times it by 3 at the bottom. So what do I have to do at the top to keep it the same?
3.
Fantastic. If you can grasp this concept of equivalent fractions, fractions will never be a problem for you again. Okay? So, I can do all sorts of things to fractions to make them bigger, to change, to play around with the numerator and the denominator, but not change the result of what I do with that division. So if I divide 1 by 2, I get 0.5. If I divide 3 by 6, I get 0.5. It's still the same number, isn't it? It's still a half. Okay? So that's what we call equivalent fractions. And we're going to utilise that today to compare apples and oranges. And we're also going to use it to add and subtract. Okay. However, when you're given questions with fractions in your paper, you might end up with an answer like 4/8. And they use this expression, simplify, or put it into its lowest terms. So what do you think they want you to do that time?
Go the opposite way.
Go the opposite way. Instead of multiplying, we're going to divide. So as long as I divide the top and the bottom by the same number, my fraction doesn't change. It simplifies it. Can everyone see that? So I've got 4/8. So what could I divide it by? 4, 2, yeah, 2, 4, both go into it. So let's do it the long-winded way. Because they're both even numbers, I know they both divide by 2. And that's kind of a general rule. So if I divide it by 2, and then divide it by 2, it becomes 2/4, doesn't it? So my fraction hasn't changed. I'm still talking about a half. And then 2 and 4, I can see I can divide it by 2 again. So if I divide it by 2, and divide it by 2 again, I end up with a half. Which is exactly what it is in its lowest terms. Can you all see that? Yeah? Mm-hmm. You want to play around with that a little bit? Ben, you're like looking at me. You okay with that? Yeah? Okay. Right. So the first one, I want you to write 2 equivalent fractions to 2/5. Don't care what they are, just show me you understand what an equivalent fraction is. The second one, I want you to simplify to its lowest terms. Okay? Simplify a fraction. And you're going to see that in a while, that almost every exam question that involves a fraction will have a throwaway line at the end that says simplify. And you're going to become experts at simplifying. Aren't they, Sharon? Okay? So the top one, I want you to create any random, whatever you want, equivalent fractions. So what do you have to do to make an equivalent fraction? What's the golden rule? Harry?
Same as the top and bottom.
Times the top and bottom by the same number. So just create any 2. I don't care what they are. It's not a textbook answer, it's just understanding. Sorry, Ben, I haven't got you on the list. Not on the list, you're not on the register. This is such a small class, it's not an issue, but there'll come a time when these lessons settle down, we won't have to hand a piece of paper around. I'll know who's doing the lesson and I'll do the register off the top of my head. But for this first few weeks, we're just capturing all these new students coming in. Okay? Any 2 equivalent fractions, I don't care what they are, and then simplify 8/12. So you've just done a calculation in your exam, the answer's 8/12 and the question says simplify it. So to simplify it, what's the golden rule to keep it equivalent? Sorry? Divide what by what? Top and the bottom by the same number.
Yeah.
And it doesn't change what the fraction is. This is the golden rule of today. If you remember anything from today, the golden rule is equivalent fractions, what you do to the top, you do to the bottom. Okay? And trust me, it will stand you in good stead for ratios, for everything else you do. Okay? Right. Equivalence, it's a wonderful thing. So, 2 over 5. Anyone want to give me any equivalent fraction? Don't care what it is. Ben, anything.
4 over 10.
Fantastic. What have you done there to get 4 over 10?
It's times it by 2.
Times it by 2, times it by 2. So 2 over 5 is exactly the same fraction as 4 over 10. Everyone happy with that concept?
Mm-hmm.
Anyone else give me another one? Anything? Shaking your head?
No, because I did the same one.
Yeah, I wanted 2.
Oh, right.
2 equivalent fractions.
8
Invent
over
another
12. 8 over 20.
8 over 20. What have you done there, Fee?
I times the 2 by 4 and the 5 by 4.
So this time we're multiplying the bottom by 4 and the top by 4. So it's not difficult, Harry. Just pick a number and just multiply the top by that number and the bottom by that number. The fraction doesn't change. It's just written in a different way that we might want to use a bit later. Okay. Simplifying then. Anyone want to start me off simplifying this one?
2 over 3.
You know better than that. Don't just sat down and answer, Sharon.
Why?
Because
What do you mean?
it's the process. What did you do to
sorry.
get it?
I've just done that.
You've just written it down. You've probably thrown away a mark in an exam. Okay, you have to show the process that you're doing things. Sam?
Well, I went the long way around because I divided the 8 by 2, which gives me
Brilliant.
4.
No, that's right. That's absolutely perfect. If you break it down into 1 or 2 stages, because you know they're both even and 2 goes into it, fill your boots. Okay, you don't lose marks because you've done it in 3 stages. If it works for you, just do it. So divide by 2 is 4 over 6.
And then I divided that by 2 again, which gives
Good.
me 2/3.
Divide by 2 again gives you 2/3. This process is what gets you the marks in the exam. What have you done to get there? If you just write down 2/3, you might lose marks for not showing what you're doing. Or, as often happens, the smart answers that think they can do it just write down an answer, and 9 times out of 10 it's wrong. And the reason it's wrong is because they haven't followed the thought process through. And as soon as you do that, alarm bells ring. Oh, I've written the wrong thing down. Yes, Harry?
If you just put divided by 4 each.
Perfect.
is that
Yeah.
right?
So if you started 8 over 12 and you just say divide by 4, and you go straight to 2 over 3, that's perfect as well. But you've got to show that working out. And this is how you drop marks in exams, okay? Right. I'm going to introduce you to a friend of mine. This friend is going to stand you in good stead in practice. I'm going to save you at least 5 minutes in every single exam you do by introducing you to this guy, prime numbers, okay? Prime numbers. What's a prime number, anybody? Prime number.
It'll only be divided by 1 and itself, like nothing will divide into it.
Brilliant.
Apart from
So
itself
it can
and
only be
1.
divided by itself and 1. That's a little bit to add on. Tiny little bit that you've missed.
Don't know.
Just like the negative thing. Or sorry, the integer thing. Not including 1. So any number divisible by 1 in itself only, but not including the number 1.
Okay.
1 is not a prime number. So what's our first prime number then?
3.
Sam? 2.
2.
Next one?
3.
Next?
5.
5. Oh, very quiet. Bit tentative. Yeah, keep
7.
going. 7, all right. 7, yeah, next. Everyone says 9. I'll
No,
tell you
it's not.
11.
11.
11, keep going. We need to go up to 30, by the way.
Oh
13.
gosh.
13, good. Keep going with it. Stick with it.
17.
17, fantastic. 19, see what they're doing, Ben? Looking for all those numbers that are only divisible by itself and 1. 23, Sharon's on a roll now.
Yeah.
27.
Close. 9, 8 and 27 is divisible by 9 and 3, 27. One more.
29.
Ah. Okay. You will need to know these. You will need to recognise these without any prompting. Okay? Because when you have a nasty fraction, if I said to you, I don't know, 23 over 40, it's a nasty fraction. Okay? I'm going to save you an enormous amount of brain power and time by saying this phrase, which you'll get sick of by the end of the lesson. 23 is what?
Round number.
Does it go into the denominator?
No.
Therefore, you can't do anything with it. Don't waste your brain power trying to simplify it. And you're going to see that 100 times today. By the end of the lesson, I'm not even going to say it. It's going to become the unmentionable thing. So recognise a prime number. Does it go into the denominator? No, it doesn't. Stop wasting your brain power. Does that make sense? And that's like a little trick for exams that will save you so much time. You get people tapping things and trying to work. It doesn't happen. Don't waste your time. If it can only be divisible by 1 in itself and it doesn't go into the denominator, you can just carry on, okay? And we're going to show you 2 examples of that. Everyone happy? Let's see if he's scribbling away. He's writing my rules
Yeah,
down.
sorry, that's it.
Sorry,
I'm
I've copyrighted that particular rule. Okay, nobody's come up with it. Like Archimedes and all that. Deanies. I just call it Deanies. Right? Okay. Okay. So we're going to look at 2 examples. I've got 19 over 42. What's 19? Straight away you're thinking.
Prime.
Does it go into 42?
No.
No, because 2 19s are 38, and another 19 is going to take me well past 42. So don't waste any brain power. That's done. You can't simplify it. Trick question. You can't do anything with it. 22 over 160.
Well, 2 will go into it.
Right, they're both even, therefore 2 must go into them. So to simplify it becomes
11 and 80.
we've got 11 over 80. Can I simplify it?
No.
Straight away you're going, no. Why? 11's a prime
It
number,
doesn't go into 80.
because I know 11's are 88. Yeah? Or 11's are 77, okay? See what I'm saying? So you're going to save yourselves an awful lot of heartache and pain by spotting prime numbers and doing them. When we did prime numbers this time last year, we went up to 20. I think halfway through the course, we did a practice paper, and it had 2 questions about the prime numbers 23 and 29, didn't it? It was like and suddenly we're up, better learn them up to 30. So blame that lot for finding that one. Okay, oh, did that fly past something? No. Okay. Right. We're now going to use our newfound skill, okay? This creating equivalent fractions, which I haven't written on there, which is a bit important because that's what today's all about. Today is all about equivalent fractions. That's what it's all about. We're going to use our skill in equivalent fractions now, okay? I want to compare 2/3 and 3/4. Okay, it's a non-calculator paper. I don't want to divide 2 by 3 and work out what it is as a decimal. And you could do it that way if you wanted to. I'm going to show you how to compare a nasty fraction with a nasty fraction. Okay, you've actually already done it. I'm comparing, in theory, this thing it was doing this yesterday. The image is kind of locked. We're comparing apples with oranges. When I'm looking at 2/3 and 3/4, my denominators, my piece of pizza is cut up into different size bits, so I can't compare them, okay? I'm comparing thirds with quarters, and it doesn't work. What we need to do is blend them, stick them in the blender and create a mix, okay? Create something that is common to both of them. So a denominator that's common to both of these, if I multiply the 3 by the 4, is 12. Happy with that? So now we're going to use our skills with equivalent fractions and create something over here and something over here as a 12th. See what I'm saying?
Yeah.
Penny's starting to drop. Yeah? So I know 12 is common to both of them,
Yeah.
so I've just blended them together to create the 12.
Yeah.
Does that make sense? Yeah? So now what I'm going to do is I'm going to convert both of these numbers into 12ths using the skills I've got with equivalent fractions. So what question do I have to ask myself over here? What is 2/3 as a 12th? Yes, Sam?
You got said like what you've done to the 3 to get the 12.
What have I done? Perfect answer. To the 3 to get to 12. What have I done to it?
Times it by 4.
So I've times that by 4. What do I have to do to the top?
Times by 4.
By 4. Banging into the wall. I have a bruised shoulder by the end of the day, okay? So is everyone happy that 2/3 is 8 over 12?
Cool.
Yeah? Everyone happy with that concept? Please nod at me. This is really, really important. Yeah? Ben, happy with that? Equivalence. So earlier on we talked about equivalence where we could multiply the top and the bottom and we get the same. This time we're saying I want the bottom to be 12. We've actually set what the bottom's going to be. So to get from 3 to 12, I've multiplied it by 4. If I multiply the bottom by 4, what do I have to do the top to keep it equivalent?
4.
Multiply it by that same 4. So 2 over 3 is identical to 8 over 12. You have to be happy with that concept. Are you happy with it? Yeah? Equivalent fractions. Right. Let's do the other one then. Doing exactly the same. Ben, what do I have to do to get from 3/4 to something over 12?
Times 3,
Yeah, by...
4.
No?
Oh, no.
Ask yourself the question, what do I have to do to get from 4 to 12? What have I done?
Times it by 3.
Brilliant. So to keep the fraction equivalent, what do I have to do to the top?
Times it by 3.
So that becomes...
9.
So in my new blended fruit juice drink, I'm looking at juices and juices, yeah? I'm looking at 12ths and 12ths. I've got 8 12ths, which is what 2/3 is equivalent to, and I've got 9 12ths, which is 3/4 is equivalent to.
That's a revelation.
Is that a revelation?
For me, it's a revelation.
Does that help? You knew that. Some people knew it. Some people are looking at it in a different way.
Cool.
Now that we can do that, and in this instance we're just comparing two fractions, which they could quite easily do. They could say, which is the bigger fraction? Here are two horrible fractions. You now know what to do with them. We're going to use this concept to put a little sign in there, either plus or minus, because it's the same concept to do addition and subtraction. You put them into the same language, and then you deal with them. So that's what we're going to do later. Don't do it just now. Everyone happy with that concept? Yeah? Let's compare a fraction then. It's going swimmingly well. We'll be out of here early. Okay? So I'd like you to tell me which of those two is smaller. So an exam question. Which is smaller? 2/5 or 3/7? Talking apples and oranges. What do I have to do? Sharon, what do I have to do? What's the first step? What do I have to create? I've got apples and oranges. I can't do it. Think of the image. What did I create? My smoothie. Create your smoothie. Yeah? So how do you create a smoothie? You blend them.
To get the 12, how did you do that before?
Right? You blend your denominators. You need to find something that the bottom fraction both goes into. Yeah?
Right.
So that you can upscale them. So here, I've got 5 and 7. What number is common to 5 and 7? The easiest way to find that out is to multiply them. Yeah? So your denominator becomes whatever the result of that is. Yes, Sam?
Do we have to simplify it, or?
Yes! If you can simplify it, simplify it. Goes without saying, if you can, brilliant. It's an unsaid rule. Yeah? Okay, that's what we're doing. Some of you haven't cottoned onto the concept as well as I thought. Okay? You need to come up with a denominator that both 5 and 7 will go into. And in the last instance, we had 3 and 4, and we blended them by multiplying them. So to get a common denominator, a denominator they can both go into, you need to blend them. You need to multiply them. So that will give you a denominator of 35. You then have to ask yourself the question, what have I done to 2/5 to make it into something over 35? And then ask yourself the same question with 3/7. The 7's gone to 35, what have I done to it? Then I need to do the same to the top. Yeah? Some of you are still struggling with this concept. You have to get a grip of this concept. It's what we do to compare fractions, to add fractions, and to subtract fractions, okay? Let's do it slow time then. Some of you haven't cottoned on to what we're doing here, okay? I've got 2/5 and I've got 3/7. I can't compare them because they're different things totally. And they're different because the denominators are different. I need to create a denominator that they can both go into. So what number is common to both of those? What did we do last time? We blended our apples and oranges. We multiplied them. So the number that's common, Sam,
35.
is 35. So this is something over 35, and that's something over 35. Because I know that goes into 35, because I've multiplied it by 7. I know that goes into 35, because I've multiplied it by 5. That's how you create a common denominator. If you multiply the two different denominators, it must create something that they can both go into. Okay? So our denominator is 35. Then what do we have to do? What's the question I have to ask myself on the left-hand side?
What did I do to the 5 to make it 35?
What have I just done to my 5 to make it 35? And what have I done to it, Fee?
Times it by 7.
I times it by 7. I multiplied by that thing. So what do I have to do to keep it equivalent?
Times the 2 by 7 as well.
I have to multiply the 2 by 7 and I get that. So now I'm talking about my fruit drink. I know I've got 14 parts of my fruit drink on that side. What do I have to do over here? Sharon, you with me? No?
Sorry, I'm just working it out.
Okay. We'll go over here then. Harry, what do I have to do over here then? What question do I have to ask myself?
How did I get from 7 to 35?
Perfect. Perfect question. And the answer is
Times by 5.
I multiplied it by 5. So to keep this the same fraction, what do I have to do?
Multiply 3 by 5.
Multiply 3 by 5, you get in there, which gives me... So now I'm comparing fruit drinks with fruit drinks, okay? So now I can look at them and I can actually say the smaller fraction is 2/5. You wouldn't say 14/35. The fraction they're interested in is this one. So my smaller fraction is 2/5. Happy? Get in there? Don't worry, you get plenty of practice because we're going to have to do the same thing when we do addition and subtraction. Yeah? It'll get it. You'll get it. And when you do get it, the penny kind of drops. The light bulb comes on. It's what they call enlightenment, isn't it, in education? Yeah. Oh my goodness, yeah. Right. I'm not going to torture you with video. Okay. Just for you, Harry. I've got a memory stick. I've got 2.5 gigs of videos that shows every single topic that you've got to cover. If you want a copy, bring a memory stick in with 2.5 gigs free, and you can have a copy. I'll just copy it. Called a remote archive in a lot of places. Okay. I'm not going to waste it. It's pretty boring, and he said exactly what I've just said. Okay. We're going to talk about the types of fractions now. Okay. An improper fraction is something we came across earlier. An improper fraction is a top-heavy fraction. Yeah? You've seen a top-heavy fraction in the first 2 minutes of the lesson, really, because we said that, didn't we? And we said there was another way of writing that, and the other way of writing that was that. Yeah? So we've already seen an improper fraction when I asked you to divide 24 by 4. The fact that I wrote it that way, at the time, you didn't actually visualise it as this. That's all an improper fraction is. In this instance, at the start of the lesson, 4 went into 24 quite neatly 6 times with no remainders. Okay. However, if I divide 3 by 8, how many times does 3 go into 8?
Twice, remainder 2.
Twice, and the remainder goes over the denominator. Does that make sense? So I've got a top-heavy fraction, which we call an improper fraction, and when I actually carry out that division, 3 into 8 goes twice, remainder 2, and the 2 goes over the denominator. So 8 over 3 is exactly the same as 2 and 2/3. Does anybody know what we call 2 and 2/3? It's a maths expression for what that is.
No.
Mixed number. And it's a mixture of whole numbers and fractions. So in the papers, you could do a calculation. It throws out this result, but the examiner is saying, make it into a mixed number. And he would expect you to go to that next step. Yeah? You happy with that? Does that make sense?
Yeah.
So we can switch. When we've got a top-heavy fraction, we can call it a mixed number. And the same way, the other way. If I've got a mixed number, like 2 and 2/3, which is a mixture of whole numbers and fractions, I can convert it into an improper fraction, because then I can deal with my addition and subtractions using just a denominator and to convert the big numbers into it. Okay? So how would I address that then? So what's the trick between this? Then okay, then Ben. Sorry, Sam.
You times the whole number by 3
So you times the whole number by 3 to get 6.
and then add the 2.
Add the 2 that you've already got, and you get 8. Keep the denominator the same. Denominator never changes. So that's switching back the other way. So I've got a mixed number which is made up of whole numbers and a bit of a fraction. To turn it into an improper fraction, a top-heavy fraction, We multiply the 2 by the 3, because that's how many thirds there are in 2. 2 times 3 is 6. There are 6 thirds that make 2, yeah? We're adding the 6 to the 2, it gives me the 8. So 2 and 2/3 is 8 over 3. Everyone happy with that? We'll do a bit more practice on those, okay? So let's go from improper to mixed again. We'll talk through this one slow time, and then I'll let you try one. Okay. So I've got 6 over 4. It's what? It's an improper fraction, and I want to turn it into a mix. So you've just done a question in the exam, you've just nailed it, you've come up with 6 over 4, and that pesky examiner has said, and I want the answer as a mixed number. What are you going to do?
How many times does 4 go into 6?
How many times does 4 go into 6?
Once.
Remainder?
2 over 4.
Is that your answer?
No.
Thank you, Sharon. Loud and clear.
Sorry.
What is my answer, Sharon?
1.5.
Thank you. Because
Simplified it.
that's my girl. That's why she's doing a retake in a couple of months. Right? Because you need to spot things like that. If you finish this question off like that, you ain't done the question. You're not going to get the mark. You need to go to that step. That's the simplifying. If it can be simplified, do the simplification. Is that okay? Understand what we're doing? A bit of scribbling. I'll let you carry on scribbling, and then I'll give you some examples to do yourselves. Yes, Harry?
Change it back to an improper.
We're going to do that in a second.
Yeah.
We'll do that in a second.
Because when you said on the times 6 on the last one,
Yeah.
I thought the bottom number would then be 6.
No. The bottom number never changes. That's always going to be the same. Whatever the fraction is we create with that, it's going to have 3 on the bottom. That's what we're trying to do. What we've done here, what Sam said, was we multiplied 3 by 2 to get 6.
Yeah.
Because if I have 6 thirds, what's that the same as? Do that. What does that mean in maths? No, it doesn't mean a half.
2.
It means 2. It means 6 divided by 3, which gives me the 2. That's why Sam's done it.
So when you times the 3 by the 2, you then put it on the top.
Yeah, the 6 becomes the number of parts you need to create the number 2. Yeah? So 3 by 2 gives me 6 over 3 that represents my 2, plus the 2 I already had, which is 8. Yeah? Some strange looks. We're going to practice that in a minute anyway. We'll carry on with this. Try going from improper to mixed. So there's 2 for you to do, and then we'll do that one again, Harry. Don't worry, we're going to cover it again and do some examples with it. Good. Good. You get there. Okay, everyone's cracking this really quickly. That's really good. I do like it when the lesson flows. This could become the lesson of the week.
Oh.
It was Thursday morning last week. This is your opportunity to
Did you
get
say
onto
we were
YouTube.
rubbish last
No, I
Friday?
put it on Thursday night. I had so many people turn up last week. I thought I better get it on YouTube sooner rather than later. But I've got a new software to edit the video and combine it with the better sound. So. Right, let's do this. Have a go. 7 over 3. Start for 10, anybody?
2 1/3.
You know I hate when you just throw answers at me.
Sorry.
You do it just to wind me up, right? 7 over 3. What do I do to get the answer?
I do 3's into 7.
Talk to me. 3's into 7 goes
Twice. Remainder 1/3.
goes over the denominator of 3. Okay? Yeah? Happy? Next one. 14 over 4. Harry, you got your hand up. I'll let you do one.
I'm sorry, do not do that.
No. I'll just. If you're looking at me, I'll
It's
ask
a
you.
habit.
Yeah, habit. Yeah, that's good enough.
Yeah.
Keep doing it. I like it.
4
Makes you feel important. 4
4
goes
into 14 3 times.
perfect. 4 goes into 14
Which leaves
3
you-
times,
Which leaves you with 2.
which leaves you with 2.
4 stays the same.
4 stays the same.
And becomes
Down again, won't it?
Yeah, I didn't do
3
that.
and 1 half.
Just dawned on you. You've
Yeah.
seen it.
Damn.
Nice one, Ben. So what does it do?
So,
You're getting there in stages. So it's all right. progressive learning.
3 stays the same.
Yeah.
It's 1/2.
For your marks, you need 3.5. Got a couple of you again. Yeah?
Yeah.
Got to simplify. If you can see it, simplify it. Ask yourself, can I simplify it every time you see a fraction? Okay, let's go the other way and I'll talk you through it again. Okay? I've got 1 2/5 and I want to convert it into an improper fraction. To get the number of fifths in the number 1, I multiply 5 by 1 and it tells me that 1 is actually 5 over 5. Can everyone see that? Yeah? 5 over 5 means 5 divided by 5, which gives me the number 1. So to get that, all I need to do is multiply 5 by 1. It gives me the number 5. I add the 5 to the 2
7
to get 7.
over 5.
And the 5 doesn't change because it's common there and it's common there. Yeah? Happy with that? Show me. Do those two for me, okay? So I've got 1 1/4 and 3 2/7, and I want you to convert those into improper fractions, the top-heavy fraction.
The other thing that's getting me is how to write it out. I get it.
Yeah.
It's just like,
So the 5 is the denominator, that doesn't change. So
Yeah.
if that's your denominator, that's still underneath, that's not going to change. I've done 5 times 1 is 5. Put it up there so that you add it with the 2. It becomes 7. Yeah? So have a go at those two and see what you get. So when you do the multiplication, the result of the multiplication, stick it over the whole number so you know that's what's being represented. Don't stick it under the number because you'll end up adding it to the denominator.
Pete,
Yeah.
you know when you times your bottom number by your whole number,
Yeah?
is that what goes on your bottom line?
No, no, no.
No,
The
it's
denominator never
whatever's on the
changes.
bottom.
So whatever's on the bottom stays on the
So
bottom.
why'd you do
So,
that then?
right.
That's what I did.
We'll talk through them, okay? We want to write that in terms of quarters because that's our denominator. That's never going to change. Even before you start, do that. Okay? So all we're saying is, I've got 1 of something. What is 1 in quarters? So if I have a denominator of 4 to represent this number 1, what has to go on the top to represent the number 1? Yeah, because 4 over 4 represents 1. So all I'm doing in theory is my little trick is I'm multiplying 4 by 1 to get this 4 here. Yeah?
Yeah, I get that bit with that one.
So I've got 4 and I'm adding the numerator of this one to this one to get
5.
5. So that's 5 over 4. Are you happy with that
Yeah,
one?
get that one.
Right, talk me through the next one then.
Right.
Okay? So I've got 3 and 2 over 7. So before you start, what's my denominator going to be for my
7.
answer? So it has to be over 7 because we're going to talk in terms of 7s, yeah?
Yeah.
Then what am I
the bit
doing?
I got confused at was obviously on that top one you've done 4 times the 1.
Yeah.
And I did the 7 times the 3.
Brilliant, which is?
7.21.
So it's 21 over 7. If I divide 21 by 7, what do I get?
3.
So 21 over 7 represents the number 3.
Right,
So the
okay.
21 is what we're interested in.
Which also goes in, yeah.
Right, so we're now talking in 7s and 7s, so they're equivalent. Yeah?
So then you do your 7 plus your 2.
No? Why am I doing 7
Right.
plus 2?
I don't know.
20.
You've just converted it into 21
Ah,
over
so you go
7,
with that
and I've got a
number.
2 over 7. So I've got 21,
plus your 2,
and I've got a 2,
which it gives you 23.
so it gives me 23 on top. Top with top, the bottom doesn't change.
So that's where I was getting confused.
You get it now as well.
Yeah.
Brilliant. Okay, I'm glad we did it 3 or 4 times, yeah. Everyone else happy with that?
Yeah.
Everyone else get that? Yeah? Fantastic. Happy days? Ah. Let's move on.
So basically, whatever you
sorry.
get from timesing your 2 numbers together, you add to your top number.
Yeah.
Yeah.
Let's say, I'll just make up one up. 2 and 1/5, right? The trick is, that Sam talked about at the very start, all you need to do is multiply this by this. When you do that, put the number 10 up there,
Right,
because
okay.
it's the numerator. You've already got another 1, so it becomes 11 over 5.
I get
So
it.
lots and lots of practice if you need it on my course. With
Is there some worksheets on
yeah,
my course?
on my course on all this stuff.
Right.
It's actually, at the top level, it's 0 to fractions worksheets. There's 2 worksheets and the answer sheet on there for
Because
you.
we're doing this today and I'll probably forget tomorrow.
Yeah.
And you have to like that.
Right. And that's what this course is all about. That's a perfect point, right? I'm showing you this now. We'll probably do a recap at the end. about what it is, and that's it. You have to go away and look at it once or twice in the week to keep that skill topped up, then look at it again in a month, and then in a couple of months, and so on. In a month, we'll be doing continuation appraisal. It could be in there. Not saying it is, not saying it isn't. In 2 months, you'll be doing it in your first practice paper. So that's another time you're going to be looking at it, okay? So we're going to do this over and over, but this first week is critical. You need to look at something 3 or 4 times in that first week. And that's what that picture was that you saw on the homework, okay? I'm not going to bore you to death with videos. Right, got 2 questions here, exam-style questions. The first one is 1 mark, so they're not particularly interested in working out. But 12 over 30, they want you to simplify it. The second one, I'll help you out a bit. This grid is 5 by 10, and that's 1 lot, 2 lot, 3 lots, and a few. Another 3 there. Okay. So that's 1 lot of 5, 2 lots of 5, 3 lots of 5, and 3 there. So they want you to convert the picture into a fraction and then simplify that fraction. And they're quite keen on those sorts of things. They'll give you a piece of pie, they'll show you 1 piece of pie, they'll say what is the fraction of this piece of pie, and then put it in its simplest terms. Stuff like that. Okay. But that diagram on the bottom, you'll get used to it later when we start looking at shapes and stuff, and pie charts and graphs, and what fraction of the pie chart is coloured in, that sort of thing. And that's how they start mixing it up a bit. I tell you, you're in danger of being in video of the week at this rate. It's going well. I think you're quite lucky, because by the time I get to the Friday, I've actually done this 4 times. So I know what works and what doesn't. Wednesday afternoon was a disaster, but that was nothing to do with the content, was it? Okay. Okie doke. Just about there.
Is it alright at this point if I don't understand it? Not this question.
This question, what don't you understand?
Sometimes I have blanks where I read it and just...
Which one, the B or the A? Which question have you got a blank with?
I don't know, just this page, I don't know. Look, is it an easy question here?
Yeah, this will be right at the start of an exam, something like this. It's asking you, it's asking you something quite straightforward, okay? Let's have a look at it then. First question, what's it asking me to do? Simplify 12 over 30. We know how to simplify now, because we have a rule for simplification, don't we? What's the rule?
Divide by 2.
Not divide by 2. What I do to the top, I do to the bottom. It might not be 2. It might be 3, 4, depending on what numbers you've got. But divide the top and the bottom by the same number, you can simplify. So what can I divide by here? Perfect answer, 2. Yeah? So I can divide the top by 2, and I can divide the bottom by 2, and that gives me
6 over 15.
Okay? Who left it like that? No. What can we divide by now?
3.
3. Because this is where your times table comes in. You need to recognise these numbers straight away. That 6 and 3, 15, sorry, I've got 3 in common. And it becomes
2 over 5.
And that's what goes on your answer line for your mark.
Does it matter if you've gone to 2 separate?
No. If you, right, so what Ben was saying, oh yeah, they're even divided by 2 is great, and you can do it in stages. But if you look at that and you know that 6 goes into 12 and 6 goes into 30, and you divide them by 6, and you get 2 over 5 straight away, that's fine as well. That's perfect. Yeah? So for this one then, all this question is saying is look at that grid and make a fraction out of the grid. So where would I start then? What would my denominator be?
The biggest, 50.
50. 10 by 5, it means I've got 50 squares in that grid. And then my numerator is my shaded squares. So how many shaded squares?
18.
18. Do I leave it like that?
No.
No. What do I have to do?
I divided by 2.
Brilliant. Divide the top by 2 and the bottom by 2, and I end up with
9 over 25.
9 over 25. Can I simplify it any more?
I think you can, but I never got that far.
No. 9 is only divisible by itself,
and it
3.
doesn't go into 25.
No, and 3.
Yeah.
So 9 doesn't go into 25,
Yeah.
and 3 doesn't go into 25.
Yeah, cool.
You can't do anything with it.
Cool.
Okay? So the answer they're expecting on there for your second mark is 9 over 25. Happy with that? Brilliant, brilliant, brilliant. And that's the first objective done, and that's really good actually. Not bad at all. Right, what we're going to do now is add and subtract fractions. But we're going to do that in a way that you're familiar with. And we're going to create equivalent fractions. Instead of comparing them, we're going to do something with them. Yeah? So earlier on I gave you funny fractions, and you just created something that was equivalent by creating a common denominator, multiply the bottom by the same number, multiply the top by the same number, and then you can compare them. All we're going to do is just stick a plus or a minus sign in there. So let's have a look. So we're going to add, subtract, multiply and divide fractions. Okay, next half hour or so, and then we'll take a break. We're going to add fractions, okay? If I'm comparing apples with apples, I can just do it. Okay? So I've got 1 apple, and I've got another 2 apples. How many apples have I got?
3.
3 apples. Everyone happy with that concept?
Yep.
So you don't have to multiply anything, make anything equivalent. They're already talking in the same language. You're comparing like with like. So if you have a fifth plus 2 fifths, add them together. Okay? Some people tie themselves in knots in exams for this. I have no idea why. Okay? They start multiplying, and I'm thinking, what are you doing? It's apples and apples. Just do it. Yeah? Happy? Happy days? Excellent. Right. Now we get to the trickies. Apples and oranges again. I'm adding an apple to an orange. Okay? Earlier on, we learned how to deal with apples and oranges by creating our fruit smoothie. So we need to create a fruit smoothie out of this. What's my fruit smoothie going to have as a base?
6.
6. So this is going to be something over 6, and this is going to become something over 6. So our answer will be something over 6. Yeah? Everyone happy with that concept?
Mm-hmm.
Equivalent fractions. Yeah? We need to talk the same language. The thing that is common to 2 and 3, we've said the easiest way to work that out is just multiply them together. So it's something over 6 and something over 6. Happy with that?
Yeah.
What do I have to do now?
The same to the top. But you
Same
go
to
the
the
bottom.
top. So I've dealt with the bottoms. So what have I done to get from 2 to 6?
Times it by 3.
So what do I have to do to my top?
Times by 3.
Times by 3 to get 3. So is everyone happy that 3 over 6 is exactly the same as a half? Yeah? Put my plus sign in there. So I've got 3 over 6 plus. What am I going to do on the right hand side?
Times it by 6, the 1. Is that right?
Why am I timesing it by 6?
Oh no, timesing it by 2. Sorry.
Brilliant. Yeah? So to get from 3 to 6, I've multiplied it by 2. So that means to keep it the same fraction, I have to multiply that by 2. Is everyone happy with that concept? We've been using it already. All we've done is we've created 2 equivalent fractions with a common denominator. Happy? Lots of smiling and nodding today. If only I had a camera facing you lot, it'd be brilliant. Right. What do I do now? I'm talking fruit smoothie with fruit smoothie. I've got 3 fruit smoothies. I add another 2 fruit smoothies, and I end up with 5 fruit smoothies. Yeah?
Yep.
Got that?
Yep.
I'll find out in a second. Everyone happy with that? Got what they want off the board? Let's try a couple. Okay. Apples and oranges. Create your fruit smoothie. Make them equivalent. Add your smoothies. Got a whole new concept of maths. I'll bring the blender in next week. Okay. Must be initial access next door. They're very loud. You feel you're learning something today? Bit of an eye-opener, a bit of a different way of doing things. Yeah? Yeah, that's what this is all about. This course is all about learning. I asked that question at the end of Wednesday's lesson. You could have heard a pin drop. You should have seen the faces. Heads hitting desks, all sorts. You just couldn't grasp it. You heard?
Yeah.
Or was it the Wednesday night one, not the Wednesday afternoon one?
Oh.
The Wednesday night one wasn't as bad as the Wednesday afternoon
Oh,
one.
right.
Wednesday afternoon was a disaster. Wednesday night actually went average, except for the dancing girls who came in. Seemed to be lagging a little bit. The adults seemed to grasp it. I think the 16 to 18 year olds were really struggling. Okay. I'm trying to do as much as I can on the smartboard because this is what's recorded. Whatever's on here is being recorded. If I do it over there, you don't see it when you come to doing the YouTube thing. So I'm trying to make these slides as big as possible so that I can write stuff on them. Okay. Everyone had a go at both, or are you still doing? If you're still doing, I'll give you a minute. Still doing? Okay. Just think of the rules. Think of the rules. Good. So you've got something over 20, something over 20. So then ask yourself, what's the next stage then? So you've got the common denominator. So what's the next question you ask? What have I done to get from 5 to... Brilliant. Yeah? And then ask yourself the same one over the other side. What have I done to get from what to what? Brilliant. Excellent. And now you're talking fruit smoothies with fruit smoothies, aren't you? Yeah? So I've got 8 fruit smoothies and 5. Yeah. So how many fruit smoothies have I got? Over your fruit smoothie. Okay, let's do these then. Some of you sort of a bit rusty. Let's do them together. What's the first step?
Times the 5 by the 4.
To create a common number to 5 and 4. Everyone happy with that? Yeah? The reason we're multiplying them is because we want to create something that they can both go into. So we've done that. We've made our denominator 20. What am I going to do next? What's my next question to myself?
We times the 2 by 5. No, by 4.
Yeah? So what have I done to get from 5 to make it into a 20? Harry?
Times by 4.
I've multiplied it by 4. What's my golden rule with equivalence? What do I have to do next?
Same to the top.
Got to do the same to the top to keep it as the same fraction. So I've got to times that by 4, which gives me 8 over 20. Yeah? Over here, my next phrase, Sam?
I times that then by 5.
So to get from 4 to 20, I've multiplied by 5. I'm doing it long-winded. You'll cut down on all this writing. So I have to multiply the 1 by 5 to get 5. I've now got 8 fruit smoothies and 5 fruit smoothies. So my answer is in fruit smoothies. And how many have I got? 13. Can I simplify it? Why? 13 is a prime number and
It doesn't go into 20.
Yeah. You've got to do that second bit and it doesn't go into the number underneath. Because if that was 26, it would. Okay. Right. Next one. Green. Okay. Talk me through it. What's the first stage then, Harry?
9 times 3.
Is
15.
so the number that is common to both of these two fractions is the number 15. Fantastic start. What's the next step? What am I going to do next?
15. Oh,
What's the question I'm going to ask myself?
what have I done to the bottom?
What have I done to the bottom to get 15?
Times it by 4.
Oh, times by 3.
I times it by 5.
Oh,
To get
sorry.
from 3 to 15, I've times it by 5.
5.
So what do I have to do to the top?
Times that by 5.
So 1 over 3 is exactly the same as 5 over 15. Equivalence. We did it right at the start. We all know what it is. The next fraction then. Harry, what have I done?
Times it by 3.
I multiply that one by 3, and that gives me what on the top?
6.
Brilliant. Okay. 2 over 5 is exactly the same as 6 over 15. I'm now going to add my fruit smoothies. The fruit smoothie doesn't change. What's on the top? Got 5 fruit smoothies and 6 fruit smoothies. It says it. I'm going to change it. Got 5 apples and I've got 6 apples. How many apples have I got?
11.
It's not easy to say. Right, pick another word. Drink. Let's call it a drink. Got 5 drinks and 6 drinks. I've got 11 drinks. Can I simplify? Because,
No.
11's a prime number.
and it doesn't go into 15. U is good. Yeah? That's brilliant. So that's addition. Guess what we're going to do with subtraction?
Same thing.
Exactly the same process. Instead of adding them, we're going to subtract them. It's easy, isn't it? It's equivalence. It's like, it's the key to the world. Yeah? Right, let's do this then. We'll do it together. What am I going to do? I've got apples and oranges. Create a drink.
Create a cocktail.
Create a cocktail. I'll even get that one wrong. Right? Summing over 6 and summing over 6. We've created our cocktail. What do I have to do next to add my ingredients? What have I done to 2 to get to the 6?
Times it by 3.
What I do to the top, I've got to do to the bottom. So a half is the same as 3 over 6. We all know that.
Mm-hmm.
This time I'm subtracting. Put a big subtraction sign in there. Next bit, the fraction on the right. I've gone from
Times by 2.
multiplied it by 2. What do I have to do to the top?
Multiply by 2.
So now I've got 3 cocktails. I'm taking away 2 cocktails. What do I end up with?
1
1 what?
cocktail.
Ah. Happy with the process. Getting
Apart
into the
from
swing
taking my cocktails away.
of it. Get your cocktails away, yeah. Can't drink these cocktails. Right. Try those 2, see how you get on. Should be quite straightforward now because we're now doing this process over and over, especially that equivalence process. And then I've got a really nasty question next before the break. It kind of fried a few people's heads. Nobody's actually given me the correct answer without knowing how they worked it out. One person blurted out the correct answer on Wednesday night, but only because I had a class full of, I had 27 people and they were all just shouting out random fractions at me. But one person hit the nail on the head but had no idea why. Stop shouting, Kevin.
No.
Stop shouting.
Who is it?
Well, it's Kevin. He teaches initial access. They have learning difficulties, so you've got harder hearing, all sorts of issues. So he's a very keen, energetic, and loud man. But he's allowed to be. He does a very good job at it. Could never do that. End up with a sore throat constantly. Right, everyone getting into the swing of these. Give you another minute or so. Yeah. Sorted, Sam. You done it this way before, Sam?
Yeah.
Yeah, excellent. Yeah, good. See, lots of good work now. Something's going in. Sounds like a roll call going on in there.
He's going to do that all day.
Yeah. But he is from Manchester, so he's used to shouting at people. Okay, seen a few pens go down, almost at the same time actually, it's quite good. You're in sync, aren't you? Right, let's do it then. Where do I start then? Who wants to start me off for 10 on that first one?
6 times 5.
6 times 5. So my common denominator, the number that's common to both of them, we've decided is the number 30. And it's a subtraction. We'll not forget that. Some people added it the other day, I don't know why. Right? What am I going to do next?
What you've done to get 30 when you times it by 6.
Fantastic, Harry, you're on it now. What am I going to do next?
Times 6 by 2.
I'm going to times that by 6 to keep it as the same fraction. So 12 over 30 is the same fraction as 2 over 5.
Yeah.
Superb. What am I going to do next?
What you've got, what you did to 6 to get to 30.
What have I done?
Times by 5.
So what do I have to do up at the top?
Times 1 by 5. Which
And
stayed at 5.
brilliant. So I've now got my cocktail, 12 cocktails. Take away 5 cocktails, leave me with 7 cocktails. What am I going to do now? Harry, talk to me. Not a no. Look at it. What can you tell me about that number, that fraction? You're always looking to simplify. Can I simplify it? Because
7's
brilliant, good start. And what's the second part of it?
They don't go into each other.
Doesn't go into 30.
No.
So always do that check. Does 7 go into 30? No, it doesn't. Yeah?
Cool.
Happy? Getting it? Get it? Got it? Next one. Anybody else? Somebody else give Harry a rest. I'm only picking on Harry. Not picking on him. I want to make sure Harry picks it up. Anybody else? Because we're all getting there. Sam, brilliant. Go for it, Sam.
I worked out that 7 times 4 equals 28.
So that becomes our common denominator. Brilliant. Yeah.
And then to get from 7 to 28, I times it by 4.
Brilliant.
And then obviously you times your 3 by your 4, which gives you 12.
Superb.
To get from your 40 to 28, I times it by 7.
You did.
And then to get obviously from my 1 to my 7, times that by 7. Yeah. And then 12 minus 7 leaves you with 5.
Yeah.
And you can't simplify it because 5 is a prime number.
And
It doesn't go into 28.
brilliant. And we know it doesn't go into 28 straight away because anything that's a multiple of 5 ends in 5 or 0. Yeah.
Mm-hmm.
Happy?
Yeah.
Oh, happy days. Happy clappy. Right. Let's do this then. Exam question, just straight out. They're going to ask you, just straight out of the blue, what's a half plus 2/5? What's a half minus 2/7? Don't mess around. They don't flour it up. Ben has got half a cake and he adds it to Joe's 2/3 of a cake. GCSE maths isn't functional skills. It's brutal. They just want the numbers. They're not interested in the flowery words. Okay? It can be brutal. It's a war out there and we're going to win it. There's another question and then a rhythm of gons. Do these out. I'll hand these out after. This will help you with your adding and subtracting gons. Yeah, we're knocking them off quite quickly now, aren't we? Yeah, what's the problem? What's the issue? Fraction. Still fraction. The fractions are the heart of a lot of problems that people have, like ratios. You've got your phone.
Oh? Yeah. I want to replacement so I can send it off.
Don't get an iPhone 6, apparently they bend.
Yeah.
Oh, top tip this morning, on national news this morning, do not do any electronic transactions, financial transactions on the internet all this weekend.
Wow.
There's a bug or a virus where it's stripping
PayPal.
people's anything. Do not do an electronic transaction on a computer this weekend. It was on the BBC Two News this morning. Sorry?
Does that go for your phone?
Same thing, it's electronic,
Everything's
isn't it?
I bought a load of stuff this morning on the phone.
What? So I can pay something over the phone?
I wouldn't.
I've got to pay a parking ticket.
Oh, do it then. If they get you
But the
details.
BBC told me not to.
Yeah, BBC, Radio
It'll go up
2
if I don't
News.
pay.
There's some virus that's out there on Macs, on PCs, and it's basically it's sucking up all your financial details every time you make a
I
transaction.
didn't know
Right.
about that, but the iPhone 16 is true.
The bending one.
Yeah.
But Apple said there were only 6 out of millions that they've sold.
There's a YouTube video of a guy doing it. Using his hands. Just doesn't.
Okay. Nice little interlude. Buy a bit of time for those still working. Let's do these two, shall we? Somebody different this time. Talk to me. Anybody? Sam, Ben, V, anything?
I'll have a go.
Go on then.
3 times 5,
Yeah.
which is 15.
So that gives us a common denominator of 15 for our two numbers. It's still an addition.
Yeah.
Yeah.
And then I times the 1 by the 5.
Yeah, because 3 goes into 15 5 times.
Yeah.
That's why we're multiplying it by 1. You don't mind if I'm not doing the arrows now?
Mhm.
We know what's going on now, do we? Yeah.
Mhm.
Okay, and then
The 2 times 3.
because 5 goes into 15 3 times 2 is 6,
And then I add the 5 and 6 together, which is 11
Over.
50.
and that's what you put on your answer line. And showing this working out gets you 1 mark. Putting that on the answer line gets you the other mark. Can we do anything with 11 over 15?
No.
No.
I'm not even saying it anymore, am I? Don't have to say it. Yeah? Start the lesson, you're thinking, what's he talking about? Now, I'm not even saying it. Okay, next one. V.
Common denominator 14.
Common is 14 to both,
So I times my 1 by 7,
because 2 went into that 7 times.
and I
Brilliant.
times my 2 by 2. I get
Get
4,
four.
and then I take away the 4, and I end up with 3. Sorry. Yeah.
I'll do the maths. You just,
Thank you.
You just talk. I'll just write.
Cheers. Thanks.
Yeah. And that
Over
goes-
14. Yeah.
And that has to go on there to get that. And can I simplify it?
No. Oh, no.
Good.
You're going to put one in that we can simplify soon, aren't I'm waiting for
Yeah,
it.
yeah, there is actually in a minute. Yeah, there is. Right. Oh, have I missed something? Oh, that's a real nasty. It must be right at the end of the lesson. I was expecting to see a nasty. Right. I'm going to hand you something you can take away. This isn't a class exercise. It's called an arithmegon, and they appear in the Sunday Times, Telegraph, the Mail. I don't think the Sun do them. I think they're a bit too
Highbrow.
Yeah. Basically, if you're sitting on a train and you want to impress people sat around you, turn to the quiz page and find the arithmegon. And I'm going to show you how it works, okay? Corner. After licking you all to death, of course, first. Right. We're going to move on. We're doing really, really well here, okay? We're going to move on now and we're going to do multiplying fractions. Okay. Multiplication of fractions is the easiest thing in the world. This will take all of about 3 seconds. What do you think we do when we multiply fractions?
Exactly the same that we've been doing.
No,
Oh, no, you don't make
exactly the opposite.
you don't make cocktails.
You don't make, well, sort of. You make a different sort of cocktail this time.
Is that going to be that stupid thing? 1,
No.
2, 3?
No, that's what addition and subtraction used to be. I've now taught you how to do it properly. You know, we used to do the Zorro thing, 1, 2, 3. You don't need that anymore because you now understand equivalent fractions. Okay? Forget 1, 2, 3. And the Jackson 5. Okay? Just
Do we just times the top and the bottom, and that's
correct.
Okay.
Easy, easy. It's kind of a cocktail, but a different kind of cocktail. Okay? 1 by 1. 2 by 3. That's all there is to multiplying fractions. Top by top, bottom by bottom.
Oh, yeah, that's the easiest one.
Cool.
Remember that one now?
Yeah.
Okay. Brilliant. Have a go. We're not spending any time doing it. That's just how you deal with multiplication of fractions. Top by top, bottom by bottom. It will take you all of 3 nanoseconds. By the time I get to the board, we'll all have done, won't we? What else will we have done?
Now that I know my 9 times table.
Ah, you're away. We'll simplify as well. Well done, Harry. Right, first one then. Anybody? Somebody? Talk to me. Sam, you want to? What's the first one?
3 over 35.
1 times 3 is 3. 5 times 7. Can I simplify?
No.
So you hesitated there.
Yeah, I
Did you
thought
think
so
about
too.
that? Always
Yeah.
think simplify. Do a fraction, think simplify. No, 3 doesn't go into 35. End of. Right. Bottom one. Anyone brave enough?
6.
Go on then, man.
Is it 6 over 82?
Not 82.
72.
Showing the trick. 72. Okay.
I'm crap with my times tables.
Can I simplify
I'll
it?
show you the 9s in a bit.
Yeah, your 9s will be great by the end of today.
Yeah.
Can I simplify?
Yeah.
I
Yeah.
have to be able to because they're both even.
2.
Divide by 2, it becomes.
1 over 12. Alright.
Wait for it, wait for it.
Sorry.
Okay, we're dividing by 2. Top by 2 gives me 3, bottom by 2 gives me.
36.
Can I simplify?
No.
Yes.
Yeah.
1 over 12.
You said no. Why did you say no?
I was thinking if I could bring it down again.
Yeah,
Because it's 3, a
Yeah.
prime number, and it doesn't go into. Well, it does go into 36.
it
but
does, and that's the trick. 3's a prime number, but it does go into 36. Yeah? Don't see a prime number and stop. Ask yourself the question, does it go into 36? In this instance, it does. Divide 3 by 3, I get 1. Divide 36 by 3, I get.
12.
Yeah? So in its lowest form, it's 1/12.
So you just divide it by itself if you come
Yeah,
to that.
so if it's a prime number and the prime number goes into that, the prime number goes into itself once, because it's only divisible by itself from 1. And if it goes into that one, whatever it is. So in this case, 3 goes into 3 once, 3 goes into 36 12 times. Okay, so 1/12 is the correct answer for the bottom one. Okay, so it's always learning. Right, dividing. Okay. Does anybody know the trick with dividing fractions? So we multiplied, and that's dead easy. That's top with top, bottom with bottom. And then we're going to divide. What's the rule with dividing? Yes,
Is it
Sam.
when you like cross it? I don't know if there's
Ooh.
something else.
Yeah, it's
So you do like 1 divided by 3 and 1 divided by 2.
not quite. but sort of, right?
One
I'm
times.
going to simplify that for you. Do you remember what it's, Sharon?
1 times 3. 1 times. Oh no, it's 2 times 3, 6, isn't it? Is it? I forgot.
That's a trick. Sam, you remember what it was?
Sort of, I think, but I'm not sure.
Yeah.
Divide your bottom by your top on each side, and then divide your bottom, then times your bottom and your top.
Close.
So
You're
that-
kind of getting there, right? We do something called inverse and multiply. Okay, so the way you deal with dividing fractions is you do something called inverse and multiply. What do we inverse?
Flipping over.
The second fraction. So the fraction doing the division, you flip it. So it becomes 3 over 1. Okay, so that's called inversing. So I've inversed 1 over 3, it's become 3 over 1. The second stage is dead easy. Our division suddenly becomes, please,
A times.
a times. So I've converted something that's quite tricky, a division, into something we've just learned is dead noddy, which is a multiplication. And I can do that by flipping the number doing the dividing. And now I can deal with it. So if I deal with this, what would I do if I was multiplying it?
3.
3 over,
2.
which is, what do we call that?
Top heavy.
Top heavy, but the proper maths expression,
Improper.
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 So in the exam, they might give you this and say, what is 1/2 divided by 1/3 as a mixed number? So you've got to this stage, you still haven't finished. It becomes
1
1
and a half.
brilliant. Yeah, talking the talk now. We're throwing these fractions around. We're converting between mixed numbers. Fractions aren't an issue because we know how to deal with them. Everyone happy with this process? So the number doing the dividing gets flipped, and then you change it from a division to a multiplication. You happy with that process? You want to try that process a couple of times? Yeah, let's go for it. Okay. So dividing, we do something called inverse and multiply. You still with me, Harry? You all right with this? Yeah. Have a go. See what you. Dead easy. Dead easy. Once you know the trick, division of fractions is never going to be a problem again. So what do I do? Good. Yeah. Perfect. And you change it from a to a brilliant, and then just deal with it like you did before with the multiplication. Yeah. It's good. Like I say, maths is all about the processes. The numbers are generally irrelevant. It's just what do you do when you see these things. And the trick between now and June is remembering what to do with these things.
Do you want to do the mixed?
No, you don't have to change them into mixed numbers. Just whatever comes out, I'll take as a result. So you probably end up with an improper fraction. Okay, let's do this then. So I've got 1/5 divided by 3/7. What does that turn into with my little rule? What's the first thing I do?
Invert 3/7.
To become,
7/3
and what's the other thing I do?
times.
And the 5th stays the same. Okay, so I've got a 5th. I'm multiplying it by 7 over 3. My multiplying fractions tells me to do what?
1 times 7 is 7, and 5 times 3 is 15.
Can I simplify it? I tell you, that door cannot just open like that. I've checked the lock 3-4 times already. I've tried pulling at it and I can't force it open. It closes proper,
Is
right?
that someone just winding you up?
What, on a Wednesday night, on a Thursday afternoon, and on a Friday
Oh,
morning? That is some wind-up.
It's someone who never passed their GCSE before they died.
Oh.
That's
And
quite a
they
lot of people.
Yeah.
From this college, a lot of people. Right, 16 to 18.
Ah.
Yeah, right. So, 7 over 15, can I simplify it?
No.
Okay. I haven't told you the statistics, Harry, about your chances of passing compared to an adult's. Right. 3 over 8 divided by 2 over 9.
So you just hang on. You just leave it at 7/15.
What can you do with it?
I don't know. That's why I was getting confused because before you were saying about flipping them back over, and I was like, well, you can't flip it.
No, we converted something into from an improper fraction into a mixed number on that last one. So all we did at the end of the last one, Sam, we had 3/2 as our answer, and all I did is I converted it into a mixed number by dividing the 3 by the 2 to create
So that's
1
why
and a
I
half.
get confused. on
Okay.
that one.
Nothing else to flip. Once you've done it, it's done. The answer is 7/15. You then ask yourself, can you simplify it? No, you can't, because 7's a prime number and it doesn't go into 15. So let's do the next one then. Anybody start off 10? Totally quiet.
So flip the 9 and the 2.
So you
So
get
it's 9/2.
9/2.
And then you times the 3 by the 9.
So you multiply the 3 by the 9. So our 3/8 divided by 2/9 becomes 3/8 times 9/2.
Yeah.
So 3 9s are
27.
and the 2 8s.
16. Now,
So-
I'm struggling here
Yeah.
to get it back to the mixed number. I've forgotten what we do.
What do we have to? What does that say in maths? What did I say that does in mathematics? What's that telling me? Remember the very first question we did in the warm up? It's the same as. It's telling me 27
divided by
divided by 16.
Right.
So you can actually do that. So to get it into a mixed number, all you need to do
It's divide that.
27 by 6. How many times did it go in?
Twice. Remain.
2 16s are 32, so that's too much. So 16
One.
goes into 27 once, remainder. Take 16 away from 27, 1 from 2 is 1, 6 from 7 is 1.
Right. Yeah.
The 16 doesn't change. Okay?
Yeah.
Good.
How you only ended up with 1 on the side?
That one there,
Yeah.
right? It's
Where
top
you
heavy,
imagine.
it's 27/16. So the answer to this question, when you flipped it and multiplied it, is 27/16. So that's what we call an improper fraction. It's the number at the top is bigger than the number at the bottom, therefore there must be a whole number in there somewhere. Okay? Because when I divide 27 by 16, it's going to go in there at least once, isn't it? It has to. 27/16 means 27 divided by 16. So when I actually carry that sum out, 16 goes into 27 how many times?
So that's where I've gone wrong.
11. Oh, what? Once.
Once. Yeah?
And then the-
So there's one whole number in there that we
Oh.
know of.
And that's,
Oh, I get you.
And then when I take that 16 that we've taken out of there away, it leaves me with 11,
Yeah.
and the 16 doesn't change.
you're just taking the whole out, aren't you?
Yeah.
That's all you're doing.
But somehow I managed to get 3 and 3/16 because I did 8. Don't ask me how or why.
Well, you can't change it into 8 because if that becomes an 8, you've divided it by 2. What's the golden rule if you're going to keep the fraction the same?
If I divide by 7.
27 isn't divisible by 2.
Right, okay.
Okay? So you can't change the denominator. Denominator comes from multiplying 8 by 2. The numerator came from multiplying 9 by 3. So we ended up with 27/16. You can't divide both by 2, so you can't simplify that bit. But what you can do, if you want to, is convert it into a mixed number by dividing 27 by 16,
Right.
which goes in once, remainder 11, leaving 11/16 at the end. Okay? Okie dokie. We're getting there. Right. Anybody tell me what a reciprocal is? Reciprocal.
If you are reciprocity is when you do something back to something
Something
that's
backwards.
been done to you.
Yeah. So if I'm going on that way, when I used to be on the aircraft, if we were flying in a certain direction, a reciprocal heading was turning around and going totally the opposite direction. In mathematics, a reciprocal is basically flipping it, and we've already come across reciprocals when we were doing division of fractions. We flipped that second fraction, the thing doing the dividing. We were calling it flipping it or inversing it. The posh word in maths for doing that is called a reciprocal. Okay? And they might put it in a paper. What is the reciprocal of 1/5? What is it?
5/1.
5/1.
Would that be your answer in an exam? No, says Sam. What about the rest of you?
I don't. Well,
It's top heavy, isn't it?
It is top heavy, so what would you put, Sam?
You make it into a mixed fraction.
Just a
I wouldn't make it into a mixed fraction. It's top heavy now. Mixed fraction. What would happen if you made it into a mixed fraction? What would it become?
5.
Ah, the correct answer is the number 5. Okay, anything divided by itself is just whatever it is. 100 divided by 1 is 100. 1,000 divided by 1 is 1,000. 127 divided by 1 is 100. So don't put the 1 there because it doesn't mean anything. Yeah, it's like we did with the pluses. I wouldn't put a plus there as well, would I? It doesn't mean anything. Yeah, I know it's a positive number. Don't put it divided by 1 because all divided by 1 means is it's just that number. Yeah, does that make sense?
What if it was a 2?
As in,
The 1 was a 2.
5
so if it was
2.
Yeah.
if it was 2/5 and I said what is the reciprocal for 2/5, what would you do?
Flip it over. 5 over 2.
And you would leave it like that. And
Yeah.
that's the correct answer.
Right.
Yeah. But if you have 1 over something and they say what's the reciprocal and you flip it because you've remembered that's what reciprocals are, and you write 5 over 1, you wouldn't get the answer because 5 over 1 is 5. Yeah. And that's an understanding of maths and how we write maths. What about this second one, which I just scribbled over, I think? They're back, aren't they, the noisy crowd? Let's do this one as well. Okay, so we know that's 5. I've got 3. What's a reciprocal of 3?
1 over 3.
Brilliant. How did you get that then?
Because it's just 1. Do you know what I mean?
Because
It's just one number.
That's invisible.
Yeah.
Yeah.
We don't put it there, but we know it's there. 3
Yeah.
divided by 1 is just 3. We just don't write it.
Yeah.
So if you've got 3 over 1, the reciprocal of a whole number of 3, you flip it. Ben got it straight away.
So with the first one,
Yeah.
when the answer's 5, if you
Yeah.
put 5 over 1, would you still get the mark?
No. Because it doesn't show you understand maths, because 5 over 1 is just 5. Anything over 1 is just anything. Yeah? Dividing something by 1 isn't doing anything to that thing. Yeah? It's like, you know, if you had 2 plus 3 and you put zeros don't mean anything. We know they're there. You and I know they're there, but we don't write them every time. In fact, I don't write that either, do I? And I don't write that. And I don't write that. There's lots of things I don't write that are there with a number. Yeah, there's lots of these invisible things. Dividing by 1, the positive sign, the power of 1, but invisible zeros that follow it. We don't write any of that, do we? Yeah. There's lots of things we don't write in maths because we're just lazy.
It is a bit lazy, isn't it?
That's why I chose maths.
Also less complicated though. If you don't why overcomplicate? You don't have
Yeah,
to
exactly.
put them all in.
Right. Need to move on. Right. First question I expect you all to be able to do. The second one is the culmination of what you've learned today.
It sounds like
I've not had the correct answer to this question from anybody that understands how they got that answer. Like I said, Wednesday night, somebody shouted out a random fraction and just happened to get it. And when I said, how did you get it? He goes, I just guessed. And you think, okay, you don't get the mark in the exam. You would get 1 mark if you put the right answer on there, but no working out. What I'd like you to do is the second part, think about it, have a go if you can, but it's all about equivalence. And it's how they've started to ask. I think 2 or 3 of the last papers have had questions like this to test your understanding, and it's all about equivalence, your understanding of equivalence. Have a go if you can. I'm going to show you how to do it if you can't, but you need to be aware of the skills that you've learned today and how you can solve problems like that. And that is what I would class as a C-star question. That's really testing your understanding of fractions, that question. Okay? So have a go at both of them. If you don't even know where to start with the second one, brilliant. Just wait and I'll show you. But the next time you see something like that, you have to recognise these questions. Okay? Yes, Sam?
I think I might have got it.
You might have got it.
Maybe.
Yeah, hold
Oh my
on.
goodness.
Wait.
The first person in 5 lessons has cracked it in under a minute.
You didn't do the first one first, did you? Did you?
Yeah.
Oh bugger, hold on.
Andy did the first one as well.
Get out of it.
That's rubbing salt into the wounds, isn't it? Those of you
next.
thinking,
I'm
yeah,
next.
I've got a grip with fractions now. And somebody like Sam goes, yeah, I've done both of them.
I've done it already.
Oh, by the way, I've got the second one right.
Oh.
And the first person, and I've got to admit, how many other people am I teaching now? 25, 50, 60, 70 odd people I've taught this week, and you're the first person to get it the right way. That's brilliant. Absolutely brilliant. 3. In fact, I'll even let you come up and play with my borders now. That's exactly.
Outrageous.
That's fantastic. I'm just so stunned. It's like really good. Really good.
I think I've got it, but
Ooh.
I couldn't
Have
show
I?
you
Hold
how.
on.
Be
Have
careful
I
about.
got it? No.
Ooh,
Oh,
you're
no.
kind of on the right track. Ooh, not quite. Right. Let's do the first one. First one's a doddle, right? First one, 3/4 times 2/5. What did we do? How do we deal with multiplications of fractions?
We just times them together.
Bottom and the bottom, top and the top.
620.
What do we do with that?
Simplify.
Halved it. What did it become?
3/10.
Yeah? Can't simplify because 3's prime number doesn't go to 10. End of. 3/10. Everyone get 3/10.
So to
Please.
simplify, we just halve.
Yeah, because you've got 6/20 and they're both even numbers.
Right.
Not every
Divide it by 2.
simplification is a halving of it. All we're saying is if you've got 2 even numbers, I know 2 goes into them both. A simplification could be I can simplify that because it's a number I can divide the top and the bottom by. And that number is 3. 3
Right.
goes into
Yeah.
6 twice, 3 goes into 9 3 times. So 6/9 is 2/3. So
Right.
don't get it into your head that simplifying is always dividing by 2. Simplifying is finding a number that goes into the top that also goes into the bottom. For example, 10/25. What goes into both of those?
5.
How many times 5 go into 10?
Twice.
How many go into 25?
5.
There you go. So simplification, don't get it into your head, it's just about dividing by 2. It's any number that goes into the top that goes into the bottom. Okay? Right. So let's insert a blank page. Can I do that? What did it do it? No. So we've got a 3rd and a 6, haven't we? Why isn't it inserting a blank page? Let's insert a blank page. Insert a blank page. Come up, young Sam. Claim your prize.
Gutted.
Superstar.
I didn't even know where to start.
I didn't even attempt to.
Okay, a 3rd and a 6. What fraction is in between 1/3 and 1/6?
What I did was make them equal.
Yeah?
So I did both under 12,
So you did them both as 12ths.
Yeah.
which would be 4,
Brilliant.
2.
Brilliant.
Yeah.
So he's made them equivalent and he's used a denominator of 12. And now you can see where the gap is. So the fraction that's in between 2 12s and 4 12s is 3 12s. And then what did you do? You've got 3 12s.
Yeah, simplified it.
So he then simplified it by dividing it by 3. And he came out with the correct answer of 1/4. And that is the textbook answer. All the marks. What have we been doing all day with fractions? We've been making them equivalent by multiplying them, haven't we? So he's made 1/6 into 2 12ths. He's made 1/3 into 4 12ths. Okay? And he's worked out that if he's got 2 12ths and 4 12ths, the fraction that lives in between them is 3 12ths. 3 12ths, when you simplify it, becomes 1/4. And we've had questions like this several times, several papers over the last couple of years. Yeah? Everyone happy with that?
Yeah.
How we did it and the sort of thought process?
How did we get the 12 again?
Well, he's just increased it. Right. I'll do it a different way then.
You found
I've got
it
1/6
Yeah.
and I've got a 1/3. I'm comparing apples with oranges.
Right.
Let's put an intermediate step in there for you, okay? Let's make them into 6. So if I made 1/3 into 6, what would it become?
2.
2/6, because I've multiplied the 3 by 2, I have to multiply the 1 by
Right.
2. Yeah?
6.
So I've got 1/6. I've got 1/6, and I'm trying to find a fraction that goes in between it and 2/6. Is there a gap? I've got 1/6, I've got 2/6.
No.
I've got no gap. So let's make them equivalent and go up another step. So let's multiply the bottom by 2 to make them 12ths. Yeah? So if I multiply the bottom by 2, what do I have to do with the top?
Same.
So 2 6 is the same as 4 12ths, 1 6 is the same as 2 12ths. Now, can I see a gap between my fractions?
Yeah.
3
What is 3 12ths? Simplified. What goes into 3 and into 12?
What?
Oh,
The number
I think I know you got
3.
3. 3 goes into 3 once, 3 goes into 12 4 times.
Yeah.
So the answer, 4 12ths.
Yeah.
Yeah? So all Sam's done is rather than putting that intermediate step in, he's gone straight to 12ths. Yeah? Or what I'm showing you on the right hand side here is I've got a third and a sixth, and we learned very early on I can't compare them, they're different things. So when I convert a third into sixths here, it becomes 2 sixths, doesn't it?
Right.
1/3 is the same as 2 6. That's the whole premise of our lesson, isn't it? Yeah? So 2 6 and 1 6, I can't see what lives in between those things, can I? There's no gap. I've got 1 and I've got 2.
So you've just times it all by 2.
So to get to 12ths, so I've times everything by 2.
Right.
The top and the bottom have been multiplied by 2 to make 4 over 12.
Mhm.
That doesn't change what the fraction is. That's what equivalent fractions are.
Mhm.
I've multiplied the top and the bottom by 2 again. So it's 2 over 12. It's the same fraction, just written in a different way. Equivalent fractions. So now I can see a gap. I've got 2 12ths, I've got 4 12ths. 3 lives in the middle. 3 12ths, when I simplify it, I can divide the top by 3 and the bottom by 3 becomes 1/4. Yeah? Super duper. Yeah?
Awesome.
Brilliant. Absolutely brilliant. Right. Those arithmegons, adding, subtracting, multiplying and dividing fractions, you can make your own up anytime you like, but you can check them yourselves as well using your calculator button. Okay? So get that scientific calculator in early, because on units 1 and 3 you can use your calculator and you will get fractions. Absolutely, definitely. Don't get a cheapie, get a
As I found last
Casio.
year.
Did it run out on the day or something? Yeah, just a
it's
Casio or
just,
something.
none of the buttons were the same, so
Ah.
we were getting confused, weren't we?
Yeah, that's right. And I put an order in for some calculators for the college, because when we were doing the exams, people would, I forgot my calculator. So we were giving them these cheap ones and we weren't getting them back. And they've got even cheaper ones this year that they've replaced them with. I've got 10 of them in the office. I'm looking at them thinking,
No
they're
good.
tech sets.
Sainsbury's last week.
I don't think the
that
batteries will
was
last.
£4 something because it were half
There you go.
price.
A Casio. Sainsbury's. Cash. No.
Starting reducing stuff.
And I still need to get one.
Okay.
Yeah, because everyone's at school and they
Yeah.
should have it already.
They're trying to clear the stocks, aren't they? In fact, I picked them up for £2.50 last Christmas, didn't I? I was
Yeah.
selling them for £2.
Christmas
I went to
is
Sainsbury's in Lytham and I bought 10 of them because they were £2.50 each, and they're normally £11.50. And I came to college and I said, you can buy them £2.50. I don't want to make a profit. And they went like that in 2 minutes. But Christmas is too late. I think you need it now rather than then. Right, fractions of an amount then. So I've got a fraction, and we know what a fraction is. It says 4 divided by 5. If I want to work out a fraction of an amount, I know that amount's going to be smaller, isn't it? Yeah, it's not going to get bigger. I'm looking for a small amount. So 4/5 of 150 in mathematics terms is saying I've got 4, I'm dividing it by 5, and I'm multiplying it by 150. That's what that means mathematically. Can you see that? Yeah? Because that's 4 over 5 means 4 divided by 5. We said that right at the outset. In maths, it really doesn't matter whether I divide the 4 by 5 or the 150 by 5 first. Okay? If I was doing it in a pure way, I would divide 4 by 5, I'd get 0.8, and I'd have to multiply 150 by 0.8. And I'd have all sorts of working out, and I'd probably have a headache. In maths, I don't have to do that first there. I can actually do it there first, and I get the same answer. So to work out 4/5 of 150, I can create a lot easier sum to do. Because if I divide 150 by 5, what is it? 30, yeah? 5 into 15 goes 3 times, and a 0 after it, yeah? I've now got to multiply it by my 4. 30 times 4, deal with your 0 first and get rid of it. What's 3 times 4? 120. So the easiest way to work out of a fraction of an amount in Unit 2, which is the mental arithmetic paper, is to do that. If you divide the 4 by 5 first, you'll get 0.8. 0.8 times 150 is a horrible multiplication to do. Okay? Your best bet to get the same answer is take the amount, divide it into the number of parts by the denominator,
Right.
and then multiply it by the number of parts you're going to eat, the
Yeah.
numerator. Yeah?
So I'm just pinching the 5.
Pinch
And
the 5. Do that first.
I only use it
Do
once.
that first.
Yeah.
Yeah? And the whole thing, you will see, is a lot easier. And especially when I introduce fractions like that. Because what's that? It's a decimal. If I did that
3.
first.
No,
3, 3, 3, 3, 3, 3, it never ends. So if you did that first, you're dealing with a really horrible decimal to
Right.
multiply that by. Yet if I have a third of 150 and I do that first, 130 divided by 3 is 50, multiply it by the 1 is 50.
Okay.
Yeah? See what I'm saying? So don't create nasties for yourselves in Unit 2. Unit 1, I don't care. You've got a calculator, do it on a calculator. Unit 2, where it's mental maths, make the mental maths easier for yourselves. And Unit 2 is the biggest stumbling block in a lot of years when we've been doing these exams. So if I said to you 2/7 of 210, have a go at that. And then somebody with a calculator tell me what 2/7 is as a decimal. So if I did the decimal first, the fraction first, see what would happen to it. We're doing on time. 11:20.
How'd you find out what decimal is?
You've got the SD button. Have you bought a new one, Sam?
Yeah.
Yeah? Yours is preset with the old fraction thing, is it?
That's
No,
what
press
she-
equal. Go to the left, so it's to the left, sorry, the right of fraction. Now press the equals. Right, and it gives you it's that, but press the SD button, and I can change that if you want. You've got an option on these Casios. This is why you need to get to understand them, right?
Yeah.
You've got an option that I can preset, that when you do a calculation, it'll give you the answer in either a decimal or a fraction.
Is that
So
right?
yours defaults to a fraction.
Mm.
So she went 2 divided by 7 equals, and it came up 2 divided by 7.
Mm.
If you press the SD button, it switches back to decimal. I can change that preset to give you an answer in a decimal, and press the SD button to go back into fractions if you want it programming.
Which is easier.
I think Sharon, you've just left yours as fractions, have you?
What?
On your calculator, when you press equals, does it give you a decimal or a fraction?
The fraction.
And then you press the SD button and it gives you in a decimal.
Yeah.
So you can do it either way. It's up to you. Okay? Alright, let's do this one really quickly then. 2/7 of 210, what's the first thing I'm going to do?
Pinch your 7.
Brilliant, and do what with it?
Put it under my 210.
So I've got 210 and I'm going to do that first. Okay, and that is
30.
brilliant. Okay, 7 into 21 3 times, don't forget the 0. And then what am I going to do?
Pinch your 2.
Fantastic.
260.
So 2/7 of £210 is 60 quid. And I've done that in my head really quick. What did you get when you divided 2 by 7? What was the number it threw out?
0.28571.
No way.
So if you did that bit first and then multiplied that by the 150, you'd have a headache in Unit
What does
2.
the little dot mean at the start and then the bottom?
It continues. That's recurring. We're going to come on to that in a minute.
Alright, so
Okay?
like
Yeah,
after
I'll
the
show
point.
you the rules on recurring and what those dots mean in a minute. And it's important because it appears on your calculator and you might be asked about what a recurring number is. Okay, so that was just finishing fractions of amounts. Have a go at that one. Dead straightforward, not tricky if you read it carefully. So fraction of an amount, we'll stick that there. Was that mother-in-law joke during the break? I've got to go and find it. My wife ever watches these YouTube lessons. I've had it. I'm a dead man. Yes.
So it's the SD.
Right, you shouldn't be using your calculator to do these.
Oh.
You can use your calculator to check them. I don't want you to use... This is Unit 2 stuff. What we're doing today, what we're doing this week, is Unit 2, non-calculator paper. So don't use your calculator to do this. Do it yourself, and then check it with your calculator. So if you've done it mentally, as in your head, great, then use your calculator to check it. I don't want you using your calculator to solve this. Okay? I want you to use your head to solve it, your calculator to check it. Okay? Don't worry about your calculators, we will get to use them in a couple of weeks when we'll have a dedicated lesson on calculators. Right, how are we getting on? Lots of ahhing. 3 marks, 3 minutes, had a good few minutes, yeah? Right, let's look at this. What's the best way to approach this one then? Who'd like to start? Start me off for 10. Start for 10. What's the first thing you're going to do? Ben, what do you do?
Not finished.
Okay.
I was setting it out like the ones previously.
Yeah?
Trying to.
Okay. Anybody?
So firstly, would you write out 7/10 of 79?
You could do, but the 7/10 relates to non-fiction books. So I'm actually interested in what?
The rest of it.
The fiction books. So how many, what percentage of, what fraction is fiction books?
Oh, wow. 3.
So I'm actually interested in 3/10 of £79, aren't I?
Right.
Yeah?
Yeah.
I'm not interested in 7/10. My answer is, what is 3/10 of 79? That's my exam question.
That's
How
right.
much did they spend on fiction books?
Yeah.
Well, they spent 7/10 on non-fiction, therefore there are 3/10 on fiction.
Yeah.
So my calculation is 3/10 of 79.
Yeah.
Yeah? Everybody got that?
Mm.
Where I'm coming from with that one?
I think I don't know if I did it the long way around or
You
if I
can
just
do.
did it
You can
wrong.
work out 7/10 of 79,
That's
and
what I
whatever
did.
you get, you take away from 79. A lot more stages and steps. We'll see if you've got the right answer, but we'll just check this first. Okay, so follow me through. So what's our trick now? What am I going to do first?
Put the 10 under the 79.
So it becomes 79 divided by 10 gives me
I got 7.9.
7.9, perfect. The trick with that, if you divide something by 10, just move the decimal place one place along.
Yeah.
So 79 becomes 7.9. I've now got a very straightforward multiplication. 7.9 times 3. Yeah.
Ah. Okay.
Yeah? Because that's what we have to do on the second part. We borrowed the 10 first, and we did 79 divided by 10 first. So we've kind of rearranged what we've got here. So that is being done like that. And now we have to do this bit and multiply whatever we get, which is 7.9 by 3. 3 9s are 27. 3 7s are 21, plus a 2, 23. So the answer is £23.70p to get all of your 3 marks. If you don't write the answer on the answer line, you won't get the marks, okay? Is that what you got, Sam? The other way around. Brilliant. Okay? I don't mind you using calculators to check you up after you've done it, but the whole point of what we're doing in these first 5 weeks is that we're using mental arithmetic, because the vast majority of students fail GCSE maths because of their Unit 2 score. The reason they fail Unit 2 is because of a lack of ability at mental maths. Okay? And it can really drag you down if you haven't got that basics. Because that mental maths helps you with the other units as well. You can see questions are wrong with the answers you're putting down because your head is saying, that doesn't look right. Things start clicking. Okay? Right. So that's add, subtract, multiply, and divide fractions. That's another little section done. We're going to finish off with a couple of little bits, okay? We're going to talk about decimals. You're doing all right. We've got, is that right? 11:27.
I haven't got the thing gone.
And this finishes at 12, doesn't it? Right, better get a lick on. Blimey. I've been a bit lax here. Right. I think we've been patting ourselves on the back too much today. Right. Decimals. A couple of weeks ago we talked about integers and place values, and if something was under this column, it represented hundreds. So in this instance, this number at the bottom, that would be 900. Yeah? Remember we said 986, what does a 9 represent? And the answer in the exam question was 900, yeah? So we knew the place values on the left. For Harry's benefit, you need to know those place values for whole numbers up to
Billion.
a billion. So 1,000 million is a billion, okay? What we're going to look at today is what happens to the right of the whole numbers. So here we finish at units and we introduce something called the decimal point. And that separates whole numbers, integers that we've already played with last week and the week before, from our decimals, our bits of a number. So everything to the right is a bit of a number. those bits have also got a place value, and that place value tells us what they're worth. So the first one to the right of a decimal point is worth a tenth. The next one is worth a hundredth and a thousandth. So it's like going the other way, but smaller. You know, it's gone 10, but it's 1 over 10, 1 over 100, 1 over 1,000. So those decimal points have a place value. And let's look at a really simple one. If I said to you 0.5, what does 0.5 represent?
5/10.
Brilliant. 0.5 is actually telling me I've got 5/10. Simplify it for me. 1, divide top by 5, I get 1.
2.
Half.
So can you see what we're doing here? We're going the other way. I've got a decimal, which 0.5 means quite literally 5 over 10, but when I simplify it, it becomes a half. So this is a reason 0.5 is a half. We mentioned at the very start, a half is 0.5 because when we divide 1 by 2, we get 0.5. This is going the other way. 0.5, when I actually say what 0.5 means, it means it's 5/10, and then I simplify it, brings me back to my half. So you can go between them, okay? Because a decimal has place values. Let's look at this one, 0.25. 0.25, what does that represent? What is it? Look at the place value.
200ths and a 10.
No, it's 25 hundredths. So 0.2 is 25 hundredths because the place value we're looking at now is hundredths. That's the smallest place value. Okay? So 0.25 represents 25 over 100. Simplify it for me.
One quarter.
Yeah?
25 goes into 100 4 times.
25 goes into 100 4 times, 25 goes into 25 once. So the reason 0.25 is a quarter, did everybody know 0.25 is a quarter? You've seen that before?
Yeah.
You've learnt it off pat, you just knew it was, nobody had ever told you why before, right? 0.25 means I've got 25 hundredths, I've got 25 of these. So when I write it out and I say 25 over 100, it actually simplifies to a quarter. So now we're switching decimals back into fractions. Does that make sense? Yeah? Everybody with me still?
Yeah.
So we can flip between fractions to decimals when we actually carry out the division, and decimals back into fractions by putting them over their place value. Yeah? Happy? Kinda? Right, let's try a couple. What is 0.4 as a fraction, and what is 5 pence as a fraction of a pound? Okay, two straightforward ones. So 0.4, what does 0.4 really mean? What's it telling me? I've got a part of a number, haven't I? So we're trying to understand numbers and fractions, and where fractions come from, and where decimals come from. So 0.4 represents something. It's not just 0.4 because it's 0.4. 0.4 is actually something else. Okay. So we'll probably go for a second. Second one, just it's kind of how they like to word things. What's 5 pence out of a pound? What is it as a fraction? Two ways of approaching it. We'll look at both ways. This one. What is 0.4 as a fraction? Yeah. So can I do anything with that, Ben? You're looking at it. What can I do with it? Whenever I see a fraction, what's my first thought? What am I going to do when I see a fraction? Brilliant. Can you simplify that?
Yeah.
Yeah. Just simplify it. Okay. Check your sums.
No.
Does that look right? Does that look? I've gone from something to something. Okay.
Okay.
Right. We'll go through them. Can't spend all day.
Oh, yeah.
I've kind of running out. I think I'm giving you too much time today. Right. 0.4 as a fraction in its first terms. What does 0.4 mean, Ben?
4 tenths.
It means 4 over 10. What can I do with that? Simplify it. So what does it become?
2 over 5.
Perfect. Can't do anything with that. That's the answer they're looking for. So 0.5 is the fraction 2 over 5. What does 2 over 5 mean? in maths?
2/5.
Not 2/5. What did we say at the very start? That means, that representation is another way of saying
2 divided.
2 divided by 5. If I'm going to divide 2 by 5, I've got 2.
Yeah.
Divide it by 5, put it in the bus stop. Does 5 go into 2?
No.
Put your decimal point in, carry the 2. Does 5 go into 20?
Yeah.
They're the same thing. We keep swapping, don't we? They're the same thing. Don't worry about fractions, don't worry about decimals. They're the same thing, just written in a different way. We just flip in between them, okay? Anyone do the second one? 5 pence is a fraction of a pound. Sam, what did you get?
0.05.
How did you get it?
Um,
So you got started off with 0.05.
Yeah.
So that's how we represent 5 pence. That's good. Okay. And then what did you do? What does that represent? What does it mean? 5 over 100. Brilliant. Because they're tenths, they're hundredths. Yeah? Or if you converted it into pence, it's 5 pence over 100 pence, because a pound is 100 pence. Yeah?
Yeah.
Do I leave it at that?
No.
What can I do?
Simplify.
So what goes into both of them?
5
How many times 5 go into 5?
once.
How many times does it go into 100?
20.
Brilliant. Absolutely. And that's it, really. You're going to need to be able to add, subtract, multiply and divide decimals. I haven't got time to show you all the techniques. I just want you to look at decimals. Generally, your decimal questions will come across in the form of money. So if you can add and subtract 2 decimals for me, to show me you've got a process of doing it, we'll fly through it. If you can't do these, you have to go away and develop them. We can't spend these lessons teaching you the techniques that you should be doing in functional skills. So treat it like money. I've got £3.12. I'm going to add £14.39. What's my answer? I've got £23.45. I'm going to take away £17.68. Again, what's my answer? So have a go at both of those. I'll give you a couple of minutes. But I'm quite conscious of the time. I didn't realise the time was kicking on so much. I thought we were doing all right. I don't know where I lost it. Okay, good. Vast majority using the column method. Good. You can do it in your head if you want to. I mean, if it's a 1 mark question, that's great. If there's a 2 mark question, you're going to have to show you working out, which you'll see in a minute. I'll show you a question in a minute from an exam paper. Okay. We'll have a look at these. So we've got 14.39, 3.12. We treat it like money. The vast majority are using the column method. £3.12. Okay? You need a method for doing this. You can't do everything in your head. You need to understand the basics of what you're doing. So we're putting things in columns. So 9 plus 2 is 11. 3 plus 1 plus 1 is 5. Put your decimal point there. 4 plus 3 is 7. And the 1 is 1. So £17.51 is the answer. Great if you can do it in your head because it's money. In an exam, they might say 3.2764 plus 5.2832. What are you going to do now? Do that in your head? Maybe not. Right. Let's look at the subtraction then. Again, using the column method, £23.45, take away £17.68. Again, start on the right-hand side. 8 from 5 you can't take away. You've got to borrow 1. 8 from 15 is 7. 6 from 3 doesn't go. You've got to borrow 1. 6 from 13 is 7. 7 from 2 doesn't go. You've got to borrow 1. 7 from 12 is 5. 1 from 1 is 0, so you don't have to do anything. £5.77. Give yourselves a big tick. Okay.
I did the only thing I plussed it.
For the second one.
Yeah.
It's funny how many people do that because it's the easier thing to do than it's like just see a plus sign or something. Right, we need to multiply and divide decimals, so have a go at those two. Again, if you haven't got a technique, we'll need to develop one for you. They will ask you nice straightforward questions like that. They're typical, just a straight off, what is this times this? What is this divided by that? So we need to nail these marks. These are the easy marks. These are the first half dozen questions in an exam. Okay. Sorry, I'm rushing a bit, but I just lost track of time. 20 minutes. Should be able to do it all. And Harry, I need you to stay back. I'll turn the machine on now so we save a bit of time. Because I need you to log you on to my course.
I know. Melted.
Okay, if you've got a process, brilliant. If you haven't, and those of you trying to use the column method for multiplying, it doesn't work. Because you can't line up the decimal point. I'm going to show you a trick how to deal with that.
Okay.
If you line up the decimal point, I'm guessing you're going to be a factor of 10 out.
Okay.
That's my guess. Okay, let's go through these slowly. 4.3 times 0.4. Anybody got a trick to deal with this? How do you start then, Sam?
I don't know if it's right though, but I dropped the decimal points out.
Brilliant. So you got rid of how many decimal points?
Just one.
I got rid of 2.
Yeah, the 2.
I got rid of 2 decimal points. We're going to have to move them back at the end.
So then I did 43 times 4.
Perfect.
But I didn't do it like that. I did it in my little stupid.
Oh, your box method?
Yeah.
No, it's not stupid. Right. You use the box method, so you've got 40 and a 3, and you've got a 4 there. So 4 times 40 is 160. 4 3s are 12 is 172.
Yeah.
Just the same as doing that.
I
Yeah.
put my decimal place back in.
So that's 1 and 2
and then
places.
2.
Yeah.
So then it becomes 1.72.
Your superb correct answer, tick VG.
Wow. Yeah.
So you've got to get rid of those decimal places and put them back at the end. Okay? Because as soon as you get rid of them, it becomes a nice easy sum, 43 times 4. Okay? If you're totally lost, if you can't get this, you've got to get good at this. Second one. Anybody try that one? Anyone think they got the right answer? Sam, you do anything for that one?
I didn't go. I was studying there.
Okay. Right, the second one, to divide decimals. Oh, Sam again, yeah?
I think I've got it.
Go on in.
Drop the decimal place out again.
So it becomes what?
12 divided by 4.
Yeah.
And then obviously 4 goes into 12 3 times.
Yeah.
And then you put your decimal place back in you twice, so then it becomes 0.03.
Right. Your
Wow.
error is putting the decimal place back.
Okay.
You were perfect up to that point,
Just
and that's
leave
it. Because it's an equivalent fraction. What you do to 1, you do to 12. 1 point. Right. If we go back to the start of the lesson, 1.2 divided by 0.4. I know you shouldn't have decimals and fractions. I'm just showing you, okay, how to visualise this. And you've multiplied the top and the bottom by the same number, haven't you? So the fraction is still the same. You know, we've been doing equivalence all lesson, yeah? And what Sam has done is she's moved the decimal point one place that way, and one place that way. So she's essentially multiplied them both by 10. So it becomes 12 over 4. So that is the same as that, isn't it? That's what equivalence is all about today. So then when she does that, 12 divided
Ends
by
up with
4,
3.
she gets 3.
Yeah.
You don't have to do anything now because it's the same. That is the same as that.
So you
That's
just
what
don't
equivalence
have to put them back.
Don't put them back.
Okay.
Yeah? Happy? So if you do something to this one and you do the same to that one, that's it. End of. Okay? So your mistake there was putting them back. Don't
I
put
just
them
find
back.
it easy to take
Yeah.
them out because you see
Yeah.
it up there.
Right. Okay, let me just stick in a blank one. That's probably what we're going
I'm going to put one on where I can't take it out now, aren't you?
Now I'm just going to just make you be aware that, right, so if I have 7 divided by 0.7, right? So how would you deal with that? You take, how many decimal places would you move?
Just one, so then it becomes
So
14.7
14.7.
divided by 7.
Perfect. So you're making that one a whole one. You're not just moving that another place, okay? That's absolutely perfect. So when I do that, 7 into 14.7, 7 goes into 14.
Twice.
Put your decimal point in, 7 is 7 once. Yeah, perfect. Yeah.
Oh yeah, I know that one.
Okay, yeah, so you're just making this, the thing doing the dividing, the whole number. That's the trick. Perfect. Here's an example of how they do it to you. This is question 6 in the exam. So we're about a third of the way through the exam, and they're going to test your decimal handling knowledge, okay? So have a go at that, 6A and 6B. So a list, a menu off a cafe. Tom buys 2 hot chocolates and 1 tea, okay? How much is it costing? And then he pays with a tenner. how much change did you get? And all this question is about is testing your ability to add and subtract decimals. And this is how it will come across in the exam. A third of the way through the exam, you should be on a high when you see all these. Like I say, the first half dozen questions are really straightforward. They're not tricky. They're just trying to relax you, make you calm down, stop your hands sweating, stop your heart racing. Didn't start at 11:30. I can't understand it. I finished yesterday afternoon 20 minutes early, and I thought they were slower than you guys. Right. I'm going to have to race through this then. So, got the breakdown there. Anybody talk me through it? First one.
A regular addition going down
So you
in the
have to
column
show, right,
method.
you got 2 marks, so
Yeah.
you have to show from what I'm working at.
So I'm adding my, I'm going down the column, so adding down the column method.
Yeah.
And I've come up with 5 down the right column. So 0 plus,
Right, he's only buying 2 hot
Two hot
chocolates and 1
chocolates.
tea.
oh, balls. Yeah, sorry. I just didn't read the
RTFQ.
questions properly.
Read the question properly, otherwise you'll throw marks away, and these are straightforward marks.
Yeah.
Anybody else then? Got £2
Two hot
for a hot
chocolates.
chocolate. What did I do with it? I can either add another one or
Yeah.
multiply by 2.
Yeah.
What did you do?
2 hot chocolates, that's £4.
2 hot chocolates is £4, so you've got to show
Plus
some
the
working
tea,
out.
£1.25.
£1.25.
That's £5.25.
Okay.
From £10.
At £5.25 here, write it on the answer line to get your answer mark. That's your working out mark. That's your answer mark. And I bet you did £10 minus £5.25 in your head,
Yeah, I did.
because every single person, adult, mature adult, just says, oh, I can do that because you made it up. You said, I added 4 to that, put 7.5 to that, and that's my change. Yeah? You've got to show it. So did you show it?
Oh, I haven't seen that.
£10
Yeah?
minus £5.25
Yeah?
equals
I didn't
£4.75.
do that before.
Okay? If you do it in your head, because you've been doing it all your life, and you can do it like that at the till, and you wrote 4.75 there without any working out, you've thrown away an easy mark. Even if you write that down and don't actually do the count,
Yeah.
write something down so the examiner can see that's what you did to get this. It's called an audit trail. Where the heck did that come from? I gave you 10, and I know that's from the last answer, but how did you get this? Yeah? Okay. Right. We're going to quickly look at rounding. What's the golden rule with rounding?
5s are up.
5s are up. Okay. Last week we did rounding of whole numbers. Today we're going to do decimal places and significant figures really quickly. We'll do it together. So if I do decimal places, we couldn't do it with integers because we didn't bother with them. But today we've been playing around with decimals, and we're going to look at rounding decimals. The rule is exactly the same. What is my first decimal place in that top number? The number 2. Yeah? My tenths. That's my first decimal place. So if I was rounding to 1 decimal place, that's the number I'm interested in. What decides whether I stick or twist?
It's
The next one along.
She's 5.
So what do I do?
Round up.
So it becomes 4.3. Don't forget this, okay? Don't forget the whole number as well. It hasn't changed. You've got to put it in. So it becomes 4.3 to 1 decimal place. To 2 decimal places, what am I interested in?
6.
The 2 and the 5 are what I'm interested in.
Yeah.
My decision is based on...
The 6.
So what do I do there?
Round up.
Round up, so it becomes
4.
2, 6 to 2 decimal places. And then finally to 3 decimal places, what am I interested in?
2, 5, 6.
The 2, 5 and the 6, what's my decision based on?
The 4,
So what do I do?
round down.
Stick up 2, 5, 6. Yeah? Happy with that? Okay? Not a trick question. What's my first decimal place on that number?
0.
The 0. I'm rounding to 1 decimal place. What am I going to
8.
make my decision on? So what do I round to?
1.
1 or
0.1.
0.1? 0.1 to 1 decimal place. To 2 decimal places, what am I interested in?
0.8.
I'm interested in
The 8,
0 and the 8. What's my decision based on?
5,
So what do I do?
up.
So it becomes
0.09.
brilliant. So that's decimal places sorted. Significant figures. What's my most significant figure in that top number?
4.
The number 4. Remember when we did whole numbers last week? It was the biggest number. We go straight to the left-hand side. So 4 is most important. What's my decision based on?
The 2.
The 2. So what do?
Round down.
Round down, so
It's 3. 4.
Stays at 4.
it stays at
Oh, it stays at 4.
4. That's to one significant figure, SF. 2 significant figures, what are they?
2,
The 4 and the 2 are the first 2 significant figures. What's the decision based on?
The 5.
The 5, what do I do?
Up.
Up to,
4.3.
brilliant, that's 2 significant figures, you've got the hang of that. One on the bottom. What's my first significant figure?
8.
Brilliant, 8. Leading zeros have got no value. So if there's 0, 0, 0, 0.0, there's nothing there, okay? So go to the first thing that means something, the 8. So if that's my first significant figure, what's my decision based on?
The 5.
So what does it become?
4.9.
Brilliant. That's one significant figure. Okay? Easily done. Sorted. So that's using decimal notation. We understand what decimals mean, and we're going to convert fractions to decimals. Right, I need to tell you about something called terminating and recurring decimals. It's a posh way of saying, if I do the calculation of 1 divided by 2, and I did it as a division, I end up with a neat 0.5, don't I? Yeah? We've talked about that before. That's it. So a terminating decimal is one that does not go on forever. It cuts off really neatly. It doesn't go to the right-hand side on your calculator. Yeah? So something like a half or a quarter are what we call terminating decimals. When I divide the 1 by the 2, I end up with 0.5. When I divide 1 by the 4, I get 0.25. Happy? That's it. So what do you think a recurring decimal is? One that goes on forever. Yeah? It doesn't stop. It goes on forever. And the thing I need to get across here, the learning point, is the fact that a nice, unsuspecting fraction like, if it's on here, 1/3, when we do the calculation, we divide 1 by 3, goes on forever, 0.3333. Yeah? If I say a third, what does it mean? It means 1 divided by 3. 3 doesn't go into 1. 3 goes into 10 3 times, remainder 1. 3 goes into 10 3 times, remainder 1. See what I mean?
Mm-hmm.
Is that what you do your DATS for?
Oh, you're a good girl. I trained you well. Right? So, to show something in maths is recurring, we put a little dot above it. And we put it above the thing that's going on forever. So in this case, 0.333333. Okay?
So if it was 0.346, 346, then you'd put it over the 346.
No, the 3 and the 6. It bounds it, and I'll show you that in a second. So 1/6, you'll have to trust me on this. If I divide 1 by 6 on a calculator, it comes out as 0.166666. So in this case, the dot will go over 6, because it's the 6 that goes on forever.
Yeah.
Nothing to do with the 1. Am I right?
Mm-hmm.
Yeah.
Oh, thank God. Okay? So, when I've got something like the 6 or the 3 that go on forever, we put the dot above it. 1/7 looks pretty unsuspecting, innocent, shall I say. 1/7. When I actually put it in a calculator, it comes out at 0.142857, 142,857, 142,587, and it goes on forever like that. It's a horrible, horrible decimal. So to show it's repeating from there to there, you put the dots on the one that it starts with and the one that it ends at. Okay? Happy?
Yeah.
Brilliant. Absolutely brilliant. So let's have a look at the first 10 fractions then. A half down to a 10. A half terminates nicely. A third is a nasty. A quarter, a fifth, and an eighth, and a tenth all terminate to nice decimals. A sixth, a seventh, and a ninth, real nasties. Which is why when we say to work out a fraction of an amount, we don't work out the fraction first and then multiply it by the amount. We take the amount, divide it by the denominator, and multiply it by the numerator. Yeah? Because, I'm not going to get you to do that, because there are some nasties. That's what I wanted to cover today. We've done it. We've got 7 minutes. Quick summary of what we've covered today. Today was really all about fractions. We've done a bit of decimal work at the end. So in order to fractions, the real key from today's lesson is this thing with the asterisk. Okay? We've got equivalent fractions. What's an equivalent fraction?
the same.
It's the same thing but written
A different
in
way.
a different way.
Cocktail.
And what's the golden rule with an equivalent fraction?
Whatever you do to the bottom, do the same to the top.
So whatever I do to the bottom, I do to the top. The fraction doesn't change, just the numerator and denominator are different numbers, okay? And we use that an awful lot to compare fractions with fractions or to add and subtract fractions, okay? We talked about prime numbers. A prime number is
A number that can only be divided by itself or 1 and not including 1.
good. So we know them and we're starting to spot prime numbers straight away and it's helping us save time. Improper fraction,
Top heavy.
top heavy, mixed number, says what it does on the tin. A reciprocal,
Flip it.
flip it, yeah, so don't forget whole numbers. Got that invisible 1 when you flip a whole number. Okay, we've done a comparison, we've done multiples and divide. Just now we've done decimals. Okay, don't forget decimals mean something. 0.5 isn't just 0.5. 0.5 means what?
Half.
Yeah, but the 0.5 means 5 what? Tenths. Yeah?
Yeah.
Tenths, hundredths, and that's how you go from decimals back to fractions. Okay, so we've done decimals and their place value, and then we've done some rounding. Okay, so that's all been done. You happy with everything we've covered today?
Yeah.
Yeah? Have you
I
got the
will.
grasp of it?
I will be, yes.
Yeah?
Yes.
Do you think you've learned something today?
Yeah.
Yeah.
Yeah? If you go away and remember one thing, remember equivalent fractions, because they come really, really useful when we get to ratios in next week and other bits and pieces, and they're the key to solving a lot of fraction problems. Yeah. Okay. Anyone got anything for me? If you've done the homework, leave it on the desk. You're not going to get homework today because we need to get to there before I hand you the homework sheet. So today's a day off. You might end up with 2 lots next week. You never know your luck. Okay. Harry, you need to stay behind and log onto a machine. I'll show you on my course. If you haven't got anything, I'll see you next week. I have no idea. It's a 9:30 start next week. We're going to go.
Take my homework.
Yeah. It's a 9:30 start next week.
Is it 9:30 for Thursday? What time's on Thursday?
You're in the afternoon, 1:30.
Yeah, that's what I mean.
Still 1:30, yeah. Okay. So 9:30 from now on. We'll go for 9:30 to 12:30. And I have no idea how many people are going to be crashing our party. And of course they won't have done anything, so they'll want to know what the heck's going on, because we're going to build on what we've done this week.
It's going to be horrible.
It is horrible doing all these things. Right.